Okay, yes, I hope I'm audible now, no? Correct. So, hello everyone. A warm welcome to one and all. Good morning. And today let us start with the new algorithm. Okay, that is K nearest neighbors. Okay, so we'll be starting with the new algorithm. Yeah, that is K nearest neighbors. Okay. चलिए तो I hope we are clear with the previous algorithms, no? The algorithms that we have studied. I hope we are clear with those previous algorithms. Okay, so today let us start with one new algorithm in machine learning, that is KNN algorithm. Okay, the full form is K nearest neighbors. Okay, the full form is K nearest neighbors. So guys, few questions have been asked, okay, in the previous papers on K nearest neighbors. Okay, so just write the heading KNN algorithm, and it is also one of the supervised learning algorithm. ठीक है, तो आप लोग heading लिखेंगे, इस पे heading लिखेंगे K nearest neighbors, and it is a supervised learning algorithm, right? So okay, so let me start with certain important points. Okay, let me start with certain important points, and I'll just give you a brief introduction of what exactly KNN is. So it is a supervised learning algorithm. Okay, the first point is that it is a supervised learning algorithm, right? And then KNN is also called as lazy learner algorithm. Okay, very important points for MCQ, that it is a lazy learner algorithm, right? And it is also known as instance based algorithm. Okay, it is also known as instance based algorithm. Just make a point here. It is also known as, right? It is also known as instance based learning algorithm. Okay, this is also known as instance based learning algorithm. Okay, acha, here I would say data is never trained. Okay, so just mark this point, that data is never trained here. Okay, only based on the instance, on that instance, based on the nearest neighbors, the decision is made. Okay, so I will just write here that data is never trained. Okay, data is never trained in KNN learning algorithm. Okay, you'll understand gradually, you'll understand, no? Once you'll be doing the questions, no, number of questions, so gradually you will get it कि why I'm saying this, कि sir data तो इसमें train होता ही नहीं है. Okay, so data is never trained in KNN learning algorithm. Okay, data is never trained in KNN learning algorithm, rather decision or prediction. Okay, rather decision or prediction. Okay, rather decision or prediction is made on a specific instant. Okay, on a specific, yeah, on a specific instance. Okay, on a specific instance, based on the nearest neighbors. Okay, based on the nearest neighbors. Okay, based on the nearest neighbors. So here I would say data is never trained. Okay, just write certain important points, no? It would help you a lot. Data is never trained in KNN learning algorithm. Okay, so as we used to train the data in logistic, ऐसा कुछ होता ही नहीं है यहाँ पे. Okay, ऐसा कुछ होता ही नहीं है. तो rather prediction is made on a specific instance based. Okay, instance. Okay, based on the nearest neighbors, right? Based on the nearest neighbors. So this is an important point here. Okay, this is an important point here. Yes, Vishal, I've uploaded, beta. I've uploaded the PDF. No, I'll just show you. I'll just show you. बच्चा, I've uploaded the PDF. आप एक बार देखिए, उसी लिंक में जाके देखिए. That link contains the PDF. आप देखिए, this is the PDF, lecture 6. Lecture 6 already I've uploaded. So it would start with SVM. You just see. I've uploaded this, no? The yesterday's PDF. Okay. So you just see once again. If not, then I'll do it again. No worries. Okay. If not, then I'll do it again. No worries. ठीक है. अच्छा. अब चलिए. अब यहाँ पर how this algorithm works. Okay, let us see how this algorithm works. चलिए अब एक बार देखते हैं कैसे algorithm work करता है. तो for example, we have a graph between y-axis and x-axis. Okay, here x is what? X is the independent variable and y is the dependent variable. So this is the data set, right? How a data set is? For example, this is the data set, right? This is the data set and this is the independent variable and this is the dependent variable. And we have certain zero classes, okay, certain classes, certain one classes, right? So we have certain zero and certain one classes. So I would say that it is a binary class target variable data set. Okay, binary class data set. I can just say that it is a binary class data set. Okay, so yeah, it is a binary class data set. So here you can see that none of the points here are actually trained. Okay, none of the points here would actually be trained here. Okay, अब देखते हैं कैसे. अब now let us understand that how this model works. Okay, let us understand how this model works. Okay. Okay, no worries, विशाल उद्धव न्यूज़बस्टर बेटा, no worries, I'll do it. Okay, आपके सामने एक बार मैं कर दूंगा, no worries. ठीक है, no worries, I'll do this. चलिए अब now let us understand how this model works. Very interesting and very good. The working is of this model, and it actually doesn't give any the importance to non-linearity, or it doesn't give any importance. They are not at all important for this. Okay, outliers. Okay, so they are actually not at all important. Right? तो अब देखो कैसे वर्क करता है. फॉर एग्जाम्पल वी हैव टू क्लासेस हियर. ओके, तो दिस इज फॉर एग्जाम्पल दिस इज क्लास 1, राइट? दिस इज क्लास 1. ओके, एंड दिस इज क्लास 2. okay, and this belongs to class 2, right? Ab now, for example, this is the unseen data, right? This is the unseen data. Okay, this is the unseen data. Ab now I want to predict that whether this data belongs to class 1 or class 2. Okay, just see the beauty of this algorithm. Without any training, what he would say, he would just ask the neighbors of this data point. Okay, for example, this is a scatter point between x and y axis. So what exactly this target point would do? The target point would ask the neighbors कि भैया तुम कौन सी क्लास को बिलोंग करते हो, तुम कौन सी क्लास को बिलोंग करते हो, तुम कौन सी क्लास को बिलोंग करते हो. तो he would be asking number of neighbors. अब how many neighbors to ask? How many neighbors to ask? So that depends on what? That depends on this value. So this is the number of neighbors. Okay, this is the number of neighbors to ask. Okay, this is the number of neighbors. Okay, what is k? K represents here the number of neighbors. तो यहाँ पे there is no training that is required in the data. Instance based होगा काम. Everything is instance based. ये जाएगा इस पे पूछेगा भाई which class you are. Okay, which class you belong to. Then he would ask which class you belong to, which class you belong to. The majority vote he would be gathering, and target point would say भैया I belong to this and this class. Okay, I belong to this and this class. So this is how the KNN algorithm works. Okay, this is how the KNN algorithm works. Now here for K, okay, I'll just write certain important points for K. Firstly, yeah, I'll just see all instance corresponds to the points in an n-dimensional Euclidean space. I'll just write. Okay, I'll just discuss this. Okay, so now certain important points for K. Okay, certain important points for K. So generally K is even for odd class target variable in the data set. Okay, and K is taken as odd, and K is taken as odd for even class target variable in the data set. Okay, k is taken as odd for even class target variable in the data set. अब जैसे for example, I'll just give an example. I mean the data set which I discussed. Okay, the data set which I discussed. For example, this is an independent variable and this is the dependent variable. Okay, and we have only two classes, 0, 1, 0, 1. We have only two classes. So that means that it is what? It is a binary class target variable. Okay, it is a binary class target variable. Now you only tell me, okay, it is a binary class target variable. Now you only tell me what should be the probable even what should be probable k values. So if it is the binary class target variable, that means how many number of classes we have? So yeah, so we have a total of two classes, right? So we have a total of two classes, binary class. So that means what is k? What is number of classes? So number of classes are 2. Okay, number of classes, how many? 2. So that means we would take a odd value of k. Okay, we would take a odd value of k. Okay, we would take an odd value of k. matlab I would take k equals to either 1, either 3, either 5, either 7, or such that. Okay, so likewise we would be taking either 1, 3, 5, 7 and more. Okay, so this is how the k value is decided based on the number of classes that are there in the data set. Okay, based on the number of classes that are there in the data set. Okay, yes, RxU, I think beta this is I think now voice would be clear, no? My this is, I mean from my end I think voice is correct. You just check at your end, no? Okay, so this is how the k is decided. Okay, this is how the k is decided. Okay, and yeah, and the algorithm is continuously updated, no, with a new training data set. As long as we'll be adding the data set, no, so continuously the algorithm would be updated, right? So we just saw here that algorithm k is just a number, no, that tells us the algorithm that how many nearby points or neighbors to look at when it makes a decision. I hope this is clear now. Okay, I hope this is clear now. Okay, अब जैसे for example I am using a 3NN algorithm. Okay, for example I am using a 1NN algorithm. Okay, just for an example that I am using a 1NN algorithm. So here this q is what? Q is the unseen data or the target point. Okay, this q is what? Q is the unseen data or the target point. So this unseen data using 1NN algorithm would belong to class black. Okay, so the prediction y hat for data q would be, it would be class black. Okay, it would belongs to what? It would belongs to class black. Okay, the unseen data would belong to what? It would belong to class black, right? Up now similarly I want to use 3NN classifier. Okay, I want to use 3NN classifier. So he would be actually seeking or asking all the three nearest neighbors, right? He would be asking all the three nearest neighbors. So he would ask this neighbor 1, this is the nearest one, then the second nearest, then the third nearest. So all of 3 belongs to what? All of 3 belongs to what? Class blue. So that means this unseen data. Okay, so that means, yeah, so this unseen data would belong to unseen data. For unseen data, y hat would be what? It would be class blue. Okay, so y hat would be what? It would be class blue. So this is how the 3NN algorithm works. Okay, this is how the 3NN algorithm works. Okay, now similarly 5NN, so it would be asking number of points. Now what exactly this asking means? What exactly this asking means? This asking means that he would be actually calculating the Euclidean distance. Okay, now to be more precise, to be more specific, I would say he would be actually calculating the Euclidean distance from the 5 nearest neighborhood points. Okay, so here what he'll do is he would be taking the Euclidean distance. Okay, he would be taking the Euclidean distance, right? So what is Euclidean distance? So this is the formula of Euclidean distance. Okay, already you know it, no? Already you know it. So I'll just give you a question. Okay, I'll just give you a question. For example, we have point 1, that is 1, 3, 4, 7, 9. Okay, and point P2. Okay, P2 is, yeah, P2 is 5, 7, 4, 3, 1. Okay, so tell me the Euclidean distance. Okay, tell me the Euclidean distance between point P1 and P2. Okay, tell me the Euclidean distance between point P1 and P2. And before that, just tell me how many number of features are there. I hope if you have developed that understanding, no, ये आप बता दोगे. अब आप इसको गलत नहीं करोगे. Just tell me what are the number of features here. कितने feature है इस data set में? If this is the data set, how many number of features are there? Okay, yeah, tell me this. How many number of features are there? तो if I want to draw the data set, मान लीजिए अगर मुझे data set बनाना है, if I want to draw the data set, no, if I want to represent this, तो I would be having x1, x2. See here, this is point 1, 2, 3, 4, 5 and 6. So a total of 6 features would be there. Okay, I hope you are getting this. So we have x1, x2, x3, x4, x5 and x6, where what is point 1? Point 1 is 1, 2, 3, 4, 7, 9. What is sample 2? Sample 2 is 5, 7, 4, 3, 5, 7, 4, 3, 1, 2, 3, 4, 5, 1, 2, 3, 1, 2, 3, 4, 5, 6. Yeah, so I'll write here 0 also. Okay, 1, 2, 3, 4, 5, 6. Yeah, so I'll write here 0 also. Correct. So 5, 3, 1 and 0. Okay, so a total of 6 features are there. This data set contains 6 dimensions, 6 attributes. So this understanding you should have now. Okay, this understanding you should have now. Now you need to calculate the Euclidean distance between point P1 and P2. आपको क्या निकालना है? आपको Euclidean distance निकालना है between point P1 and P2. So how to calculate? How to calculate? So very simple. For calculating Euclidean distance, so I would be just taking the first x1 independent vector, that is 1 minus 5 whole square plus, yeah, 2 minus 7 whole square plus 3 minus 4 whole square plus, okay, 4 minus 3 whole square plus 7 minus 1 whole square plus 9 minus 0 whole square. Okay, so just calculate. I need answer. Okay, I need answer. So what would be the answer? Yeah, so if I just open all these brackets, so I'll be getting 16 plus 25 plus 1 plus 1 plus 36 plus 81. Okay, so tell me the answer. What answer you will be getting? Okay, so 12.64, correct. 12.65 approx, correct. ठीक है, so 12.649. So this would be the Euclidean distance. Okay, 12.649 units. So this would be the Euclidean distance. Okay, this would be the Euclidean distance between point P1 and P2. Okay, this would be the Euclidean distance between point P1 and P2. Now, if you need to calculate the Manhattan distance, okay, please calculate the Manhattan distance. How to calculate Manhattan distance? Because this measure is also used in certain references. Okay, in certain references this measure is also used. So what is the Manhattan distance? Very simple. Whenever you want to calculate Manhattan distance, so that would be mod of 1 minus 5 plus mod of 2 minus 7 plus mod of 3 minus 4 plus mod of 4 minus 3 plus mod of 7 minus 1 plus mod of 9 minus 0. So that would be how much? 4 plus 5 Okay, yeah, this would be how much? 4 plus 5 plus 1 plus 1 plus, yeah, it would be 1 plus 6 plus 9. Okay, तो 4 5 9 9 और 1 10 10 और 1 11 11 और 9 20 और 6 26. तो Manhattan distance would be 26. Okay, so these two measures are important for calculating the nearest neighbors. Okay, please write the formula, and for number of features this is how we need to calculate it. ओके तो गाइस चलिए लेट मी शो यू वन इंटरेस्टिंग थिंग. आपको बहुत मजेदार चीजें दिखाता हूँ एंड रियली यू वुड फील रियली वेरी कॉन्फिडेंट. ओके चलिए एक मजेदार चीज आपको दिखाता हूँ. यहाँ पे आई थिंक आई हैव डिस्कस्ड विद माय प्रीवियस स्टूडेंट्स, नो, इन माय प्रीवियस बैच स्टूडेंट्स. तो आई एम गोइंग टू शो यू कि व्हाट एग्जैक्टली क्वेश्चंस आर आस्क्ड. ओके, व्हाट एग्जैक्टली क्वेश्चंस आर आस्क्ड इन the machine learning interview. Okay, if you are applying for any job, no, that contains certain certain machine learning position, or that is associated with certain machine learning position, right? So there are certain questions that are asked and very important questions. और जो कि मैं नहीं कह रहा, I am not saying, मैं नहीं कह रहा ये ऐसा LinkedIn पे the persons who are working, no, the persons who are working there as machine learning engineer, data scientist, वो ऐसा बोल रहे हैं, मैं नहीं कह रहा. I am just going to tell you how important this subject is and what all topics you have covered. Okay, just spare 5 minutes with me. You would really feel very, I mean, yeah, very confident. देखो ये मेरी LinkedIn की प्रोफाइल है. This is my LinkedIn profile. मैं झूठ नहीं कह रहा. I am not lying. This is my LinkedIn profile. And you can just search Pratham Chandrarte. He is, I think, I think he is one of the candidates who is working as data engineer, or I think machine learning engineer. No, somewhere he is working. अब देखो what he says कि 80% of machine learning candidates get rejected because they can't answer these questions. Okay, now let us see. Okay, now let us see certain questions which he says. What is the first question he is saying? Core machine learning में what is bias variance trade-off? आप एक चीज बता दो guys, आप ये बता दो, हैव यू स्टडीड दिस बायस वेरिएंस ट्रेड-ऑफ? आई होप आप इसको अगर आपने पढ़ा है तो दिस इजीली यू कैन आंसर दिस टू एनी ऑफ द इंटरव्यूअर. ओके, देन सेकंड इज हैंडलिंग इम्बैलेंस क्लासिफिकेशन डेटा. तो ये आपका थोड़ा सा डेटा साइंस की तरफ जाएगा. दिस वुड बी मोर टुवर्ड्स डेटा साइंस, राइट? प्रिंसिपल कंपोनेंट एनालिसिस फॉर डायमेंशनल रिडक्शन, ये हम पढ़ेंगे, वी विल बी स्टडिंग दिस. अच्छा, बेस थ्योरम, नेव बेस क्लासिफायर आज ही खत्म करेंगे. अच्छा, रिग्रेशन एनालिसिस, लीनियर लॉजिस्टिक. बताइए आपको क्या इसका बेसिक नहीं पता? आई एम डैम श्योर इफ यू हैव स्टडीड माय लेक्चर्स और एनीवन लेक्चर्स वेयर, मतलब जहां पर इफ यू हैव स्टडीड दिस मशीन लर्निंग सब्जेक्ट, नो, तो 100% आपको लीनियर का भी, लीनियर रिग्रेशन का भी बेसिक्स पता है. यू नो द बेसिक्स ऑफ लीनियर रिग्रेशन अलॉन्ग विद द बेसिक्स ऑफ लॉजिस्टिक रिग्रेशन. रेगुलराइजेशन टेक्निक L1 L2 बताओ पढ़ा है कि नहीं पढ़ा गेट के लिए? आई एम डैम श्योर अगर आपने ये मशीन लर्निंग का लेक्चर देखा है तो यू मस्ट हैव स्टडीड L1 एंड L2. ओके, चलो अब एक आप सर्च करना, मैं नहीं कह रहा कुछ भी, ये मेरी प्रोफाइल है एंड दिस आई हैव टेकन अ स्नैपशॉट ऑफ सुरभि वलेचा. यू जस्ट सर्च सुरभि वलेचा ऑन लिंक्डइन. भैया ये यहाँ पर इसने डाला था. आई थिंक शी इज वन ऑफ द मेंटर स्पीकर एंड देयर एज अ डेटा साइंटिस्ट. आई थिंक शी इज देयर. ओके, ही सेज the role is data scientist at Google. CTC देख लो भाई, खुद ये बोल रही है, मैं कुछ नहीं कह रहा. She says CTC is 30 lakhs to 30 LPA to 40 LPA. ओके, ये इसका CTC है. इंटरव्यू क्वेश्चंस. ओके, चलो इंटरव्यू क्वेश्चंस. हार्ड, इजी तो छोड़ दो, इजी तो आप आराम से निकाल दोगे. लेट अस सी द हार्ड लेवल क्वेश्चंस. क्वेश्चन नंबर 11. ओके, आई विल जस्ट जूम इट. क्वेश्चन नंबर 11, हार्ड लेवल क्वेश्चन में क्वेश्चन नंबर 11. व्हाट इज क्वेश्चन 11? क्वेश्चन 11 सेज एक्सप्लेन द डिफरेंस बिटवीन बैगिंग बूस्टिंग. कल ही हमने किया है. आई होप अगर आपने लेक्चर देखा होगा इन क्वेश्चन तो ये आपके लिए बहुत चुटकी में बजा के कर दोगे. वेरी सिंपल, नॉट एट ऑल डिफिकल्ट इफ यू हैव स्टडीड मशीन लर्निंग सीरियसली. ये क्वेश्चन कुछ भी नहीं है यार आपके लिए. सेकंड क्वेश्चन, व्हाट इज वैनिशिंग ग्रेडियंट प्रॉब्लम, ये हम करेंगे CNN में, हम करेंगे ये चीज. ओके, ये सब CNN के क्वेश्चंस हैं. या प्रैक्टिकल कोड में क्या क्या पूछते हैं, इंप्लीमेंट KNN एल्गोरिथम फ्रॉम स्क्रैच इन पाइथन। बेटा ये वाला तो आपका जो है ना मशीन लर्निंग में नहीं, ये कोडिंग आपको करनी पड़ेगी, बट इफ यू नो द बेसिक्स ऑफ KNN, आपको अगर कुछ भी खंगाले आप आराम से निकाल दोगे। आई एम डैम श्योर अगर आपको कोड में खंगालेगा ना कि वाई यू यूज 3NN, वाई डिड यू यूज 5NN, मैं गारंटी दे रहा हूँ आप आराम से निकाल दोगे। ओके अच्छा चलो, इजी वाला तो मैं गया ही नहीं, इजी तो आप सारे निकाल दोगे इजी लेवल पे, ठीक है। चलिए अब नाउ लेट अस सी वरुण रास्ते, ये डेटा साइंटिस्ट है, आई थिंक इन वन ऑफ द गुड कॉर्पोरेट्स ही इज वर्किंग। वरुण रास्ते, आप एक बार इसको सर्च कर लेना लिंक्डइन पे, देखो डेटा साइंस इंटरव्यू क्वेश्चन में क्या बोलता है, एक्सप्लेन द रोल ऑफ सेंट्रोइड, दिस विल स्टडी, ओके दिस विल स्टडी, या ये अभी वो क्लस्टरिंग का है वो हम पढ़ेंगे, ठीक है। अच्छा अब यहाँ पे निखिल नागनौर, ओके मतलब आई जस्ट वांट टू शो यू कि हाउ easy it would be once you study the machine learning no basics। तो ये सारे neural networks पे हम ये करेंगे, we'll be studying this, okay। तो I just wanted to show you that certain snapshots which I took कि that your hard work would not go in vain। आपकी मेहनत, क्लासेस में आना, क्लासेस में वेट करना whenever I get late, और इवन लंबे टाइम तक रहना, दिस वोंट गो इन वेन, दिस वोंट बी वेस्टेड, ओके। एंड आई जस्ट शो यू अ प्रैक्टिकल डेमोन्स्ट्रेशन, भाई ऐसा क्वेश्चन आ रहा है तो यू जस्ट वर्क हार्ड, एवरीथिंग वुड फॉल इन लाइन, ओके। चलो ओके, तो दिस इज मैनहट्टन डिस्टेंस, राइट। चलिए दिस इज द मैनहट्टन डिस्टेंस, ओके। अब जो है लेट अस do one example, okay, let us do one example on KNN, right, let us do one example on KNN। अब यहाँ पर what he says that we have a total of 4 points in the data set, okay, this is the data set, so we have a total of 4 points in the data set, right, P1 P2 P3 P4, okay, yeah, and here he says that if we have two variables, right, how many features are there, we have two features in the data set, okay, how many features are there, we have two features in the data set। अच्छा अब here point P1 7 7 7 4 3 4 1 4, okay, and this is the target variable, right, this is the target variable, okay, bad good good। अब now this is the unseen data, point 5 is the unseen data, and I want to predict that whether point P5 belongs to which class, whether it belongs to class good or bad, using what, using KNN algorithm, okay, using what, using KNN algorithm। So now before using KNN algorithm, what we'll do is let us calculate the Euclidean distance, okay। हम कैसे करेंगे, we would be calculating the Euclidean distance, किसका Euclidean distance, Euclidean distance of point P1 with point P5, Euclidean distance of point P2 with P5, P3 with P5, P4 with P5, and this is the Euclidean distance 4 5 3 and 3.6, okay, these are the Euclidean distances। अच्छा अब हमको क्या करना है, अब हमको what we have to do, we have to rank them, okay। अब आपको क्या करना है, अब आप क्या करोगे, अब रैंक करोगे, तो I would be ranking, तो for ranking I can say that the nearest point, what is the nearest point, this is the nearest point, so we have rank 1, okay, this point P3 has a rank 1, okay, point P3 has rank 1 because it is the nearest point from the unseen data, ठीक है। then इसके बाद we can say that P4 has rank 2, okay, P4 would be ranked 2, then similarly, okay, likewise I can say that P1 would rank 3 and P2 would rank 4, तो ये 4 रैंक्स हो गई, ठीक है बच्चा। तो these are the 4 ranks here। अब what we have to do, अब now for example if I use 1NN algorithm, okay, if I use 1NN algorithm, I'll ask from you, okay, if I use 1NN algorithm, right, so what is the prediction, so 1NN algorithm means only a single nearest neighbor would be viewed, so that means I would view P3, and what is the class of P3, that is good, so that means the prediction using 1NN algorithm would say that it belongs to class good, okay, so 1NN prediction algorithm says that it belongs to class good। then if I use 3NN algorithm, okay, if I use 3NN algorithm, so using 3NN algorithm, the first 3 nearest points, okay, the first 3 nearest points, so yeah, so I would just take rank 1 good, Okay, then what is rank 2? P4. Point P4 is rank 2. He also says that this point belongs to good. And what is rank 3? Point P1. P1 says that it belongs to class bad. So what is the majority voting? Okay, what is the majority voting? Majority voting is that it belongs to class good. So that means 3NN algorithm also says that it belongs to class good. Okay, 3NN algorithm also says that it belongs to class good. ठीक है, 3NN algorithm also says that it belongs to class good. ठीक है, तो अब इसी तरीके से if I would have used 4NN, अगर मैं 4NN यूज करता, अगर if I would have used 4NN, generally we don't use 4NN. Okay, generally we don't use 4NN because if class it is a binary class variable, तो we generally go for odd number of classes. Okay, we go for odd number of classes. ठीक है, तो if I would have used 4NN, then यहाँ पर एक टाई हो जाता. Okay, here then a tie would be there. Okay, तो अब यहाँ पे just I'll write in case of tie. अगर मान लीजिए टाई हो जाता है, ओके, इन केस ऑफ टाई व्हाट यू हैव टू डू, इन केस ऑफ टाई, तो व्हाट यू हैव टू डू, तो यू हैव टू बेसिकली सी इन केस ऑफ टाई, तो वी वुड बी गोइंग with the initial ranks. Okay, we would be going with the initial rank or initial ranks. अगर टाई हो जाएगा, if there is a tie, तो we would be going with the initial rank or initial ranks. Okay, तो अब यहाँ पर here what was the initial rank? Initial rank 1. Rank 1 says that P5 belongs to what? P5 belongs to class good. Okay, rank 1 says that yeah, P5 belongs to class good. Okay, acha, what does rank 2 says? Rank 2 says that yeah, what is rank 2? P4. P4 says that it belongs to class good. When P1 is also saying class good, P2 is also saying, matlab P1, yeah, rank 1 is also saying class good, rank 2 is also saying class good, so that means, so I would be going with the initial ranks. Okay, I would be going with the initial rank, so I would say that it would belong to class good. Okay, so this is how you have to approach, or this is how you have to approach whenever a tie occurs. Okay, so never get never get confused whenever a tie occurs. Just see the initial rank or ranks. ओके, जस्ट सी द इनिशियल रैंक और रैंक्स. अब सर आप ये कहो कि सर मान लो इनिशियल रैंक में भी टाई हो गई, कि रैंक तो पॉइंट 1 बोल रहा है गुड और रैंक 2 बोल रही है बैड, तो जस्ट सी द सिंगल रैंक, द फर्स्ट रैंक. ओके, देन जस्ट सी द फर्स्ट रैंक. तो इफ दिस इज द केस, तो सबसे आप एक ही रैंक देखना. ओके, द फर्स्ट वन इज व्हाट द फर्स्ट वन सेज, दैट वुड बी द फाइनल आंसर. ओके, तो दिस इज हाउ यू हैव टू सॉल्व द प्रॉब्लम, right? This is how you have to solve the problem. Okay, classification problem using KNN algorithms. Okay, classification problem using KNN algorithms. ठीक है, just note it down. I'll wait for 2 minutes. आप इसको लिख लीजिए. या एक्चुअली न्यूज बस्टर, एक्चुअली सी यू हैव टू सॉल्व टाई. नो, अब आपको गेट में अगर टाई हो रहा है तो यू हैव टू सॉल्व इट एट एनी कॉस्ट. नो, तो दिस इज द मेथड हाउ टाई इज रिजॉल्व्ड. ओके, दिस इज द मेथड हाउ टाई इज रिजॉल्व. तो आप इसको इसी तरीके से याद कर लो फॉर गेट पॉइंट ऑफ व्यू. Yes, sure, Harshit. I'll explain it. I'll explain. Just don't worry. I'll explain. Okay, chale, I'll explain once more. Yeah, see Harshit, no, how to solve KNN algorithm with k equals to 3. See, firstly what we'll do is, this is the unseen data that we have. Okay, so what we'll do is, we'll actually take the Euclidean distance from point P5 to P1, P2, P3 and P4. Okay, so after taking this, I would be ranking. Okay, now the Euclidean distance of P3 with P5, that is 3. Okay, so I'll just rank this as 1. Then similarly, the distance of P5 with P2, that is 3.6. So I'll rank this as 2. Okay, point P4 as 2. Then similarly, the distance of point P5 with P1 is 4. I'll rank it 3. And point P5 with P2 is 5. I'll rank it 4. Okay. Now 3NN says what? 3NN says ki bhai, what are the 3 nearest neighbors? Okay, what is the majority voting of these 3 nearest neighbors? So this exactly 3NN says. So basically 3NN, according to 3NN, they rank 1. That means point P3 says what? P3 says that it belongs to class good. Okay, then what rank 2? Rank 2, that means point P4. What point P4 says? P4 says that P5 belongs to class good. And what rank 3? Rank 3 is P1, and P1 says that it belongs to bad. So that means we have 2 good and 1 bad. So what is the majority voting? Majority voting is that it belongs to class good. Okay, Harshit, I hope beta this is clear now. ठीक है, चलिए. अच्छा, अब यहाँ पे we just saw that if at all a tie occurs, as we saw in 4NN, तो we have to take the initial rank. Okay, we have to consider the initial rank or initial ranks. Okay, अच्छा, अब यहाँ पर एक important question ये आता है कि sir, what is the effect of increasing k? I mean, where should we take, मतलब should we take 3NN, should we take 1NN, मतलब what should be the effect, है ना, कि what is the effect of k? देखिए, अब if a very I mean if we are using a small value of k, okay, if we are using the small value of k, okay, so just make two columns, no, so I'll just give you 2 to 3 points, right? I'll just give you 2 to 3 points. Yeah, so I'll just give you 2 to 3 points. Small k, what is the effect of small k, and what is the effect of large k? Okay, what is the effect of small k? Yeah, and what is the effect of large k? Okay, yeah, this is small k and the effect of large k. Okay, so I'll just give you certain points, no, that you can write. Okay, so when k is small, what is the effect of small k on the model? So we have low bias and a high variance. Okay, so when k is small, no, when k is small, okay, yeah, so small k means that it uses very few neighbors. Okay, so that means it would be having low bias. Okay, so what small k means? That we are using very few neighbors. Okay, few neighbors are used for prediction. Okay, so just remember that whenever we are using few neighbors, no, so their bias of the model would be low. Okay, bias of the model, okay, bias of the model would be low. Bias of the model would be low, but variance would be high. Okay, variance would increase, right? Whenever k is small, so this you have to remember, because we are only using very few neighbors, no, so that means it would be having very low bias, because जो पहले point ने बोल दिया, पहले 2-3 point ने बोल दिया, that would be the prediction. Okay, that would be prediction. So that means bias of the model would be low. Okay, but variance may be high because the on the unseen data the errors can be high. Okay, on the unseen data errors can be high because it rely on very few neighbors, no? So because unseen data relies on very few neighbors, I hope you are getting this, no? Ki unseen data relies on very few neighbors. Why variance would be high? Because unseen data relies on very few neighbors. Okay, so I can say that the variance of this would be very high. Okay, now if we see this for a large value of k. Okay, if we see this for a large value of k, so here bias would be more because model would be taking the majority voting. Okay, it would be taking the majority voting of number of neighbors. Okay, so here bias would be high. So this you have to remember because more number of neighbors, no, more neighbors will be asked. Okay, more neighbors will be asked for predicting the data. Okay, तो इसका मतलब क्या हो जाएगा कि bias would be higher on the higher side. Okay, bias would be on the higher side. Okay, but here variance would be on the lower side, right? Variance would be on the lower side. Okay, variance would be on the lower side. This you have to remember. Okay, so bias would be higher side, but variance would be on the lower side. Okay, okay, now when large value of k is used, when data is noisy and we want a robust model. Okay, when large value of k is used, so it is used when data is noisy. Okay, data is noisy and we want a robust model. Okay, when data is noisy and we want a robust model, and when k values, small k values used, if dataset is already clean, no, and well separated. Okay, if dataset is already clean, if data set is already cleaned, okay, it is a cleaned data and well separated. Agar well separated data hai and if it is already clean, so then a small value of k is used. Okay, so there a small, yeah, and a high value would be used. Okay, yes, killer beta, what is the wrong statement? Please tell me if anything is wrong here. Okay, so k is what? K, I can say it is a hyperparameter. ठीक है, what is k? K is a hyperparameter. ठीक है. Okay, k is a hyperparameter. Okay, so that we have to decide. Okay, so I can just say that, yeah, k is a hyperparameter that we have to decide. So I'll just write it here, the value of k. Okay, so k is a hyperparameter that we have to decide. Okay, K is a hyperparameter that we have to decide, right? अब now we can just say classification is delayed till a new instance arrive. That is why it is known as instance based algorithm. Okay, it is classification is delayed in till a new instance arrives. Okay, that is why this is known as instance based algorithm. ठीक है, इसीलिए हम इसको क्या बोलते हैं, दैट इज वाई इट इज नोन एज इंस्टेंस बेस्ड एल्गोरिथम. ठीक है, तो ये हो गया था. अच्छा, क्लासिफिकेशन डन बाय कंपेयरिंग फीचर वेक्टर्स of the different points and target function may be discrete or real valued, right? Target function may be discrete or real valued. ठीक है, तो these are the features. अच्छा, अब हमने यहाँ पर we studied for classification, right? We have seen for classification. Now how to actually solve the regression problems. So if at all we have to do the regression, no? If at all we have to do the regression, okay, if at all we have to do the regression problems, so there we take mean value. Okay, if at all we have to take the regression, we have to use the mean value. Okay, so just keep this thing in mind that mean value would be utilized in the regression problem using KNN. Okay, mean value would be utilized, okay, in the regression problems using KNN. For example, we have I mean 2 and 4 value as the nearest points. Okay, for example, this is the first nearest point. Okay, this is first nearest point. Okay, and this is the second nearest point. Okay, this is first nearest point and this is the second nearest point. So what would be the regression? What would be the problem? Regression, the answer, final answer, that would be how much? 2 plus 4 by 2. So this would be the final answer. Okay, so we have to take the mean in case of regression. Okay, using KNN. तो we have to take the mean in case of regression using KNN. ठीक है बच्चा, तो ये आपको याद रखना है. तो this you have to remember. In case of regression, this is how we solve it. Okay, चलिए. अब now let us solve question number 1. Okay, please everyone, let us solve question number 1. Okay, let us solve question number 1. Everyone, okay, please try this. So what he says, we have to use 3NN algorithm, and what is the unseen data? Unseen data is given. Okay, we have to use 3NN algorithm and unseen data is given here. Okay, we have to use 3NN algorithm and unseen data, no, that is given here. Okay, chaliye. Ab now we have to use x1 new, that is 3, x2 new, that is 7. We have to predict whether this data, for example, this is point q. Okay, this is point q. We have to predict the q here. Okay, y hat q. We need to predict y hat q. Okay, we need to predict y hat q. So very simple. So what we'll do is we would actually calculate the Euclidean distance. Okay, how to do this? We would actually calculate the Euclidean distance here. Okay, let us calculate the Euclidean distance. ठीक है, let us calculate the Euclidean distance. Very simple. How to calculate Euclidean distance? So Euclidean distance is of point q with first point. Okay, q with first point, second with first point, third with first q point, and fourth with the point q. Okay, so calculate the Euclidean distance first. Okay, so I'll just tell you the answers. What are the answers for Euclidean distance? Acha, here just a second. No, we have one misprinting here. Just take this as 8. Okay, just take it as 8. Okay, because that same point is labeled as 0 and that same point is labeled as 1. I think that is a misprinting here. Okay, just take this distance. Yeah, just take this distance as 8. Okay, answer won't change. Answer won't change. Just take this distance as 8. Okay, chaliye. Ab now, what is the Euclidean distance? So this Euclidean distance would be 4. Okay, how to calculate Euclidean distance? So Euclidean distance of q with point 1, that is how much? That is 7 minus 3 whole square plus 7 minus 7 whole square, so that is how much? That would be 4. Okay, similarly we need to calculate this. So 7 minus 3 whole square plus 8 minus 7 whole square. Okay, so this would be how much? 16 plus 1. Okay, so this would be under root of 17. So this Euclidean distance is how much? This is under root of 17. Okay, that is under root of 17. Then next is 1. Okay, next Euclidean distance is 1, and the last one is 2. The next is 3. Sorry, Euclidean distance is 3, and the last one is 3.6. Okay, the last one is 3.6. Okay, the last one is 3.6. Now based on this I would be ranking. Okay, based on this I would be ranking. So you can see here the least Euclidean distance. Okay, the least Euclidean distance, that is 0.3. So I would be ranking this 0.3 as 1, rank 1. Okay, I would be giving the 0.3 as rank 1. I would be giving 0.2 as rank 2. Okay, 0.4. Yeah, so I would be giving 0.4 as rank 2. I would be giving 0.1 as rank 3. Okay, and I would be giving 0.2 as rank 4. Okay, I would be giving 0.2 as rank 4. Ab what he says that I have to use 3NN classifier. So okay, so take the majority voting of the first 3 nearest point. Okay, so the first point belongs to what? Belongs to 1. Okay, the first rank belongs to class 1, the second rank belongs to class 0, and the third rank belongs to class 0. So what is the majority voting? Okay, what is the majority voting? Majority voting would be it belongs to class 0. Okay, the majority voting would be it belongs to class 0. So this is how we have to solve KNN classifier problems. Okay, this is how we have to solve KNN classifier problems. ठीक है बच्चा, this is how we have to solve KNN classifier problems. करिए बेटा, इसको नोट करिए. चलिए, solve second question. Okay, solve one more question. Do a big one. No, I'll just give you one of the big questions. No, at least you can. Okay, chaliye, now let us solve this question. Okay, it would actually check your calculation accuracy also. Okay, beta, just try this one. Okay, try this one, and okay, take this as 3.42. Okay, this value as 3.42. Yeah, and 7.93, 0.79. Okay, now tell me what is the answer for this new data, x1 and x2. Okay, now tell me what is the answer for this new unseen data set. Okay, everyone, please tell me what is the answer for this unseen data set. Everyone, कर दो एक बार मेरे सामने, कर दो विशाल, कर दो. You take 3 to 4 minutes. एक बार मेरे सामने कर दो, मेरी बात मान के. Just see how much good you are there in calculation, no? How fast you can calculate. एक बार बस मेरी बात मान के कर दो. चलो देखते हैं सबसे पहले कौन बताता है. Okay, last question from my side on this type. ठीक है बच्चा, last question है. एक बार कर दो, मेरी बात मान के ये वाला क्वेश्चन बताओ कितना आ रहा है आंसर. तो ऑलवेज नेवर कैलकुलेट मैनहट्टन डिस्टेंस, कभी भी शॉर्टकट यूज मत करना. दो आंसर्स आर सेम, ओके, दो आंसर्स आर सेम. इफ यू यूज मैनहट्टन डिस्टेंस हो तब भी आंसर ऑलमोस्ट वही आएगा, बट जनरली वी यूज यूक्लिडियन डिस्टेंस. ओके, तो नेवर गो फॉर शॉर्टकट. ओके, नेवर गो फॉर शॉर्टकट, जनरली वी यूज यूक्लिडियन डिस्टेंस. ओके, नेवर गो फॉर शॉर्टकट. चलिए, तो आई जस्ट मेक द यूक्लिडियन डिस्टेंस कॉलम. ठीक है, मैं यूक्लिडियन डिस्टेंस का कॉलम बनाता हूं, एंड आई विल ऑल्सो स्पेसिफाई द रैंक्स. ठीक है, आई विल ऑल्सो स्पेसिफाई द रैंक्स. ओके, तो आई विल गिव यू 2 to 3 minutes. करिए बेटा, एवरीवन प्लीज ट्राई दिस. Okay, so I'll just write all the values. Okay, I'll just write all the values. Yeah, you just check. So I'll just write all the values and never go for shortcut. Okay, always calculate the Euclidean distance only. Okay, so yes, so values would be here. Yeah, values would be 4.81. Okay, the first value is 4.81. Then we have 5.22. Then we have 6.75. Then we have 4.96. Then 5.83. Then 1.48. Then 2.35. Okay, 2.35. Then 1.37, 0.3 and 2.57. So if I rank all these things, so rank would be in this order. It will start from 6, and yeah, it will be 6, 8, 6, 8, 10, 7. So rank is 6, 8, 10, 7, 9, 3, 4, 2, 9, 3, 4, 2, 1 and 5. So these would be the ranks. Okay, yeah, this would be the rank. So now if you just see what exactly the 3NN would predict, so I'll just take rank 1. Okay, so rank 1 says it belongs to class 1. Okay, what is rank 2? Rank 2 says it belongs to class 1. And what is rank 3? Rank 3 says it belongs to class 1. So what is the majority voting? So majority vote says, what is the majority vote? Majority vote says that it belongs to class 1. Okay, what does majority vote says? It says that it belongs to class 1. Okay, correct hai? Yes, Newsbuster, that is correct. Okay, it belongs to class 1. So yeah, so P9, okay, so he will be taking P9 and P8 and P6. Okay, P9, P8 and P6. So these all points we would be taking here. Okay, these all points we would be taking here, guys. So now remaining questions I give you as homework. बच्चा ये आपको करना है, that is on the same concept. तो एक आप ये करोगे homework, then you would be doing simple questions है, आप एक बार कर जरूर लेना. Okay, just try to do this. Okay, these are simple questions. Okay, now here we have to calculate the continuous value. Okay, this is a regression question. Okay, this is a regression question. Okay, that is a regression question. So here we have to use x15, x23, x22, and we have to calculate y hat value. So here a regression question is, this is a regression question, right? This is a regression question. So I would be taking the mean values. Okay, I would be taking the mean values, okay, of the first 3 neighbors, right? I would be taking the mean values of the first 3 neighbors. Okay, I would be taking the mean value of the first 3 neighbors. I think this we can do, right? Yeah, this we can do. Yes, Veda, I'll upload it, beta. I'll upload it today itself. Okay, I think I have done it yesterday, but I'll just see it once more. Okay, because every one of you are saying that it hasn't been uploaded. I'll do it. Okay, just don't worry. So we have to just see the mean values. Okay, so this also I'm giving you as the homework, right? Chaliye. Again, this question also as the homework, because they are on the same concept. I won't be discussing it again, right? Chaliye. Acha, ab now next concept is Hamming distance. Okay, the next concept is the concept of Hamming distance. Okay, chaliye. Acha, ab now what exactly Hamming distance is? Now, till now what we have done? Till now we have done where we had continuous values. Okay, till now what we have done where we had the continuous values. For example, I have 3 features. Okay, x1, x2, x3, and this is the target variable y. Okay, this is the target variable y. Acha, ab now if you see here that we have certain continuous values. Okay, if you see here that we have certain continuous values till now what we have done. Okay, just say for example the data set for sample 1, yeah, if for example if I just take point P1, no, so for example we had 2, 3, 5 and then the class label was 0. Then for point 2 we had, for example, we had point 5, 6 and 4, the class label was 1. Okay, now if the data set contains, so this is what this is the continuous feature values. Okay, we had continuous feature values. Okay, now for example if the data set contains the categorical feature values. Okay, for example if the data set contains categorical feature values, jaise I'll just show you. For example, we have 3 features. Okay, yeah, for example we have 3 features, that is x1, x2, x3, and this is target variable y. Okay, now for example I have a feature that is known as x, feature is y and z, and the class label is 0. Okay, this is for point P1. Point P2 says I have the value y, x2 is x and x3 is again z. the class label is 1. Now if the categorical values are there as the feature values, okay, so if the feature values are categorical, okay, feature values are categorical, so in that case, if the feature values are categorical, so in that case we never take the Euclidean or Hamming distance. Okay, we never take Euclidean or Hamming distance. Rather what we do is we go for we rather take Euclidean and and Manhattan distance. So we rather go for Manhattan distance. Okay, we rather go for Hamming distance. Okay, we rather go for Hamming distance in these scenarios. Okay, so till now what we were doing, we were actually calculating Euclidean or Manhattan, right? So ab now we won't be because we can't calculate, no, because these are certain categorical values we cannot calculate. So what we'll do is we'll go for Hamming distance. So what are Hamming distance? It is a metric used to measure the distance between two categorical data points. Okay, used to measure the distance between two categorical data points. Okay, and this is particularly useful when data involves discrete features like classification tasks involving strings, binary vectors, or nominal categories. Okay, or nominal categories. Okay, so there we use Hamming distance, right? Ab now how to use Hamming distance? So you should be clear with this concept that the Hamming distance between two strings of equal length is the number of positions which the corresponding elements are different. I'll just tell you. Okay, I'll just tell you using a question. For example, we have a data set. Okay, for example, we have this binary data set and I have 3 features. Okay, a total of 3 features are there, right? So a total of 3 features are there. So what is my feature 1? Feature 1 is that X1 owns a car. Okay, what is feature 1? That X1 owns a car. What is feature 2? Has a pet. And what is feature 3? Uses social media, right? And it is a binary class target variable which involves yes and no for buying a product. Okay, which involves yes or no for buying a product. Acha, ab now I want to check that it is very clear that the data is categorical. Okay, the feature values are categorical. Okay, the feature values are categorical. Yes, for example, feature 1 is 1 and 0. It is of the form 1 and 0. Feature 2 is of the form 1 and 0. Feature 3 is of the form 1 and 0. Okay, and it is a binary class target variable. So now here Hamming distance is calculated. Okay, and we have to test point is 100. So at 100, when person has a car, person doesn't has a pet, and person doesn't use social media, whether he would buy a product or not. Okay, whether he would buy a product or not, so we have to use 3NN classifier. Okay, we have to use 3NN classifier. So let's see how to do this. See here, distance, firstly what we'll do is we'll calculate distance of the test point X, distance of the test point X from point A. How to do this? See, now I'll just tell you that, for example, I'll just tell you for a single point. Okay, I'll just tell you for a single point. For example, we have 2 features, X1, X2, and a target variable Y. Okay, point P1 is what? For example, point P1 is what? Point P1 is 0, 1. Okay, and what is the Q point? Q point is 0, 0. Okay, so ab Hamming distance between point P1 and Q, Hamming distance between point P1 and Q, how to calculate it? Whenever the category value is same, whenever the category value is same, we have to take a Hamming distance as 0. Okay, whenever the category value is same, we have to take the Hamming distance as 0. So here 0 and 0 both are same, I would be taking a Hamming distance as 0. If category value, for example, X2 and 0, the category values are different. Okay, X2 is 1 and the test point has a 0, so I would be taking a Hamming distance as 1. So total Hamming distance between point Q and P1 would be how much? It would be 1. Okay, it would be 1. So this is how we calculate Hamming distance. Okay, this is how we calculate Hamming distance. Okay, now let us see. Now let us see that, for example, here we have to calculate the Hamming distance. Okay, just see here, just don't get confused, just see here. Okay, now here we have to calculate Hamming distance. So between point X and A, what is X here? So I'll write X. What is X here? X is 1, 0 and 0. This is X. Okay, what is X? 1, 0 and 0. Ab now, if I compare 1 with 1, Hamming distance is how much? Hamming distance is 0. So I'll write here. Hamming distance is how much? Hamming distance is 0. Then 0 and 0. Again, Hamming distance is 0. Then 1 and 0. Hamming distance is 1. So overall, if I combine overall 0 plus 0 plus 1, so Hamming distance would be how much? It would be 1 here. Okay, it would be 1 here. Again we'll see, just don't get confused. Again we'll see the Hamming distance between B and X. So 1 and 1, Hamming distance is 0, plus 0 and 1, Hamming distance is 1, plus 0 and 0, Hamming distance is again 0. So here what is the Hamming distance? Hamming distance between point X and B, that would be 1. Again with third point, 1 and 0, Hamming distance would be 1. 0 and 0, Hamming distance is 0. 0 and 1, Hamming distance is 1. So what is the Hamming distance here? Hamming distance is 2. Fourth point, okay, 1 and 0, Hamming distance is how much? 1. 0 and 1, Hamming distance is 1. 0 and 0, Hamming distance is 0. So what is the total overall Hamming distance? That is 2. Okay, so what is the overall Hamming distance? That is 2. Okay, so here after calculating the Hamming distance, I would be ranking in the ascending order. Okay, after calculating the Hamming distance, I would be ranking in the ascending order. Ab now for point ABCD, I'll just make here now for point ABCD. So what are the points? Yeah, points are, what are the points? Points we have are A, B, C and D. Okay, and what are the Hamming distance that we have? What are the Hamming distances that we have? So Hamming distance is, for point A, the Hamming distance is 1. For point B, the Hamming distance is 1. For point C, Hamming distance is 2. And for point D, Hamming distance is 2. Now I would be ranking these. Okay, अब मैं क्या करूँगा? I would be ranking. Okay, in the ascending order. Okay, I would be ranking in the ascending order, and it is better to give the same ranks to the same Hamming distance. Okay, so try this practice. No, just practice it. मतलब it would be better. My question won't go wrong. Okay, question won't go wrong. So give same ranks to the same Hamming distance. For example, we have Hamming distance as 1, so I would be ranking this as 1. Point B, again I would be ranking this as 1. Point C, I would be ranking this as 2. And point D, I would be ranking this as 2. Okay, point D, I would be ranking this as 2. Okay, up now what he says? He says that we need to use 3NN algorithm. He says that we have to use 3NN algorithm, and we have to calculate the class of the unseen data. तो just see first 3 ranks. पहली 3 ranks आप देख लो, first 3 points with the initial ranks. So this is the rank 1 says. Rank 1 says what? Rank 1 says that it belongs to class yes. Okay, then again rank 1 says that it belongs to class no. Then what rank 2 says? Rank 2 says that it belongs to class yes. Okay, so here the answer would be yes here. Okay, here the answer would be yes. But now you would ask question, sir, why didn't you choose the 4th rank? Because that is also rank 2. है ना? That is one of the very question, most probable question that you would ask, sir, why didn't you choose this rank 2? Because that is also rank 2. So in the data that is given in the order, I would be taking that order only. Okay, just try to remember this. जिस order में data दिया हुआ है, जिस ऑर्डर में डेटा दिया हुआ है, द ऑर्डर इन विच द डेटा इज गिवन, ओके, द ऑर्डर इन विच द डेटा इज एक्चुअली पोजिशन्ड, इन दैट ऑर्डर आई वुड बी ओनली टेकिंग. अगर इसमें सी, इफ सी पॉइंट इज गिवन अबव डी, तो आई वुड बी टेकिंग सी पॉइंट ओनली. आई वुड बी एलिमिनेटिंग पॉइंट डी while using 3NN algorithm. okay, while using 3NN algorithm. Okay, so guys, please note this point. There are certain 2-3 points important for Hamming distance. Ki if at all this is the order in which data set is given, I would be taking the first 3 ranks in the increasing order. Okay, so just I would be I'll be just eliminating point D, since though it has a rank 2, okay, though it has rank 2, but in this order data was given in the table, I won't be taking this. So for solving this KNN problem using Hamming distance, this shall be your approach. Okay, so what would be the final answer? Final answer would be that the point Q, the point X belongs to what? Point X belongs to class ES. ठीक है बच्चा, तो point X belongs to class ES. Yeah, strictly follow the order, correct, in the Hamming distance. तो we have to strictly follow the order as it is given. Okay, जैसा दे रखा है बस आपको वैसा ही follow करना है. I hope this makes sense now. Okay, I'll wait for a minute. If anyone wants to write, please write it. Then let us start with 1 or 2 questions. Okay, chali, now let us solve one more question. Okay, try this question and give me the answer. We have to use 3NN. Okay, we have to use 3NN, and I'll tell you the unseen data. Actually, unseen data is not given here, no? Unseen data is yellow, red, red. Yes, this is the unseen data. Okay, this is the unseen data. This is the Q, and you have to predict y hat Q. Okay, this is unseen data. You have to predict y hat Q using 3NN. Okay, using 3NN. Okay, and also tell me using 5NN. So give me 2 answers using 3NN and also tell me using 5NN. Okay, so give me 2 answers. Okay, everyone, Try this. So whenever we have to attempt this question, make a separate column, okay, of Hamming distance. Make a separate column of Hamming distance, and here one more column of rank. ठीक है, one more column of rank. चलिए, okay, do this. Okay, so let's see how to do this. Very simple. We have to just calculate the Hamming distance. Okay, we have to calculate the Hamming distance. So how to calculate the Hamming distance? So yellow, red, red. Okay, yellow, red, red for x, y, z respectively. So yellow, red, red. Okay, so total is 3. Similarly, yellow, yeah, x is yellow, red and red. Okay, total is 2. Then yellow, red and red, total is again 2. Yeah, for fourth point, yellow, sorry, yeah, okay, yellow, red, red, right? So for fourth point, yellow, red and red, total is 3. Then we have yellow, red and red, total is 2. Then we have yellow, red and red, total is again 2. Then we have yellow, yeah, red and red, total is again 3. Okay, so this is how the points would be. Okay, this is how the Hamming distance I would, so it would be 3, 2, 2, 3, 2, 2, 3, 3, 2, 2, 3, 2, 2, 3. Point fifth is, I'll just check. Acha, that is 1 only. Okay, okay, this would be 1. Okay, this won't be 2, this would be 1. Yeah, I've written it wrong. Okay, so that would be 1. Yeah, so that would be 1. Otherwise everything is correct, only this would be 1. Okay, so yeah, this would be the Hamming distances, right? So these are the Hamming distances: 3, 2, 2, 3, 1, 2, 3, 3, 2, 2, 3, 1, 2, 3. Now based on this I would be ranking, है ना? based on this I would be ranking. Okay, so what are the ranks? Ranks would be how much? Ranks would be, I'll just this rank point fifth as 1. Okay, I'll just rank point fifth as 1. Then I would be ranking this as second, this as second, and this as second. Then I would be ranking this as third, this as third, and last one as third. Okay, so these would be the ranks that I would be writing. Okay, so these would be the ranks that I would be mentioning here. So 3 2 2 3 1 2 3. Okay, 3 2 2 3 1 2 3. So these are the ranks. Now based on the ranks, yeah, correct, Harshit, correct. Now based on the ranks, I have to predict using 3NN. So using 3NN, now what are the first three ranks? So this 0.5 says it belongs to class yes. Okay, then yeah, 0.2 says it belongs to class no. Then again 0.3 says it belongs to class no. So based on 3NN, what is the class label? Based on 3NN, what is the class label? That is no. Okay, based on 3NN, what is the class label? That is no. Now let us check for 5NN. So I'll check for two more ranks. So I have rank 2 for class 6. So it says that it belongs to class no. So we have 3 no, 1 yes. And what is the fifth rank? Okay, what is the fifth rank? Now all the 2's are over. Now I'll take the first third rank. Okay, the first third rank, and P1 says that it belongs to class yes. So I have 1 2 3 no's and 2 yes. So that means 5NN also says that it belongs to class no. Okay, 5NN also says that it belongs to class no. Okay, 5NN also says that it belongs to class no. Okay, so this is all from my side on KNN algorithm. Okay, and I have certain more questions on these similar types. So this you have to do as homework. Okay, this you have to do as homework. This again you have to do as homework. Okay, this again you have to do as homework. And I would just give certain remarks. So it is highly effective inductive inference method. Okay, just write this word, important hai, for noisy training data and complex target functions. So inductive inference method, abhi ke liye you just remember it. Okay, I'll just ask you, abhi ke liye you just remember it. I won't go that deep in here. Okay, then yes, learning is very simple, classification is time consuming. Okay, and I'll write certain more points here. I would write, yeah, it is slow and memory hungry. Okay, why? Because it is slow and memory hungry algorithm. Okay, this is slow and it is also called as a memory hungry algorithm. Okay, it is slow and called as a memory hungry algorithm. It is sensitive to scaling and irrelevant features. Okay, these are certain important points. Sensitive to scaling, okay, and irrelevant features. Sensitive to scaling and irrelevant features, right? It is sensitive to scaling and irrelevant features. It is sensitive to outliers. Okay, it is also sensitive to outliers. Okay, I hope you are able to get this, no, why this is sensitive to outliers, because it actually takes the nearest neighbors, no, so it actually takes the nearest neighbors. So that means it is sensitive to outliers. Acha, it is effective for non-linear and non-parametric problems. Okay, please write this also, effective for non-linear data. Okay, what is non-linear data? Which cannot be linear, which is not linearly separable. Okay, effective for non-linear data. I hope yesterday we saw non-linearly separable data, non-linear and non-parametric data. Okay, that is effective for non-linear and non-parametric data. Acha, effective on small to medium sized data, right? Effective for small to medium sized data. I'll write it, effective for small to medium sized data only. Okay, effective for small to medium sized data. Okay. Okay, and it is also called as that it is a zero model building process. Okay, zero model building process. ओके, इट इज अ जीरो मॉडल बिल्डिंग प्रोसेस, ठीक है, इट इज अ जीरो मॉडल बिल्डिंग प्रोसेस, ठीक है, इट इज अ जीरो मॉडल बिल्डिंग प्रोसेस। See, actually, no. Yes, second point. Yes, lucky. Exactly. Second point is that see, it is a non-parametric algorithm. Okay. So, what is a non-parametric algorithm? Yeah, this is non-parametric data. So here, actually, this actually explains the essence that it is a non-parametric algorithm. ओके, इट एक्चुअली मतलब ये बताता है टारगेट फंक्शन जो हो गया फॉर अ होल स्पेस मे बी डिस्क्राइब्ड एज अ कॉम्बिनेशन ऑफ लेस कॉम्प्लेक्स लोकल अप्रोक्सीमेशंस। मतलब वी डजंट यूज नंबर ऑफ एजम्पशंस, हम कोई बहुत ज्यादा एजम्पशंस यूज नहीं करते हैं, ठीक है, वी डजंट यूज नंबर ऑफ एजम्पशंस, तो दैट इज व्हाई इट इज अ नॉन पैरामेट्रिक एल्गोरिथम, ठीक है। तो ये वही चीज बता रहा है, ठीक है, कि इट इज एक्चुअली कॉम्बिनेशन ऑफ लेस कॉम्प्लेक्स लोकल अप्रोक्सीमेशंस, तो बहुत ज्यादा हम कोई इसमें एजम्पशंस यूज नहीं करते, तो दैट इज व्हाट दिस इज सेइंग, दैट इट इज अ नॉन पैरामेट्रिक एल्गोरिथम, ठीक है। आप इसको छोड़ भी दो, ठीक है, दिस इज जस्ट आई मीन डेटा साइंस पॉइंट ऑफ व्यू, ओके, दीज आर पॉइंट्स मोर रिलेटेड टू डेटा साइंस, ओके, तो अगर आप छोड़ भी दोगे देयर इज नो वरी, ओके, बहुत ज्यादा इंपॉर्टेंट नहीं रहेगा। अब गेट में किस लेवल का क्वेश्चन आया है, आई वुड जस्ट टेल यू, गेट में देख लो एक बार लेवल, क्या लेवल है क्वेश्चन का, आई जस्ट टेल यू, ओके, एंड आई वांट यू टू सॉल्व दिस क्वेश्चन, देन वील टेक अ ब्रेक ऑफ 15 मिनट्स, ओके। तो पहले एक बार आप जो है गेट का मुझे बता दो क्वेश्चन करके, बहुत सिंपल है, नॉट एट ऑल डिफिकल्ट, ओके, टेल मी द क्वेश्चन। गेट का जो लेवल है मैं आपको दिखा देता हूं, जो इन्होंने पूछा है, ओके, द लेवल दैट दे हैव आस्क्ड, नो, आई जस्ट टेल यू, आई थिंक 2024 में आया हुआ है, शायद 25 में नहीं है, yes, I think that is in 2024, okay. Yeah, this question they have asked in gate, ये क्वेश्चन पूछा था, तो yes, I want everyone to solve this question, yes, everyone, this question they have asked in gate, करिए, NAT type question है, I'll just give you 2 minutes, okay. ये क्वेश्चन आया था गेट 2024 में, या, तो दिस वाज आस्क्ड इन गेट 2024, ओके, एवरीवन शुड टेल मी द करेक्ट आंसर इन द फर्स्ट अटेम्प्ट, बहुत मुश्किल नहीं है बेटा, बहुत इजी क्वेश्चन है, आई थिंक एवरीवन ऑफ यू कैन टेल मी। Chaliye, how to solve it? Let us see how to solve this. Let's see what he says. He says we have a two-dimensional data set. Okay, he says that we have a two-dimensional data set. Okay, he says we have a two-dimensional data set, right? And I'll just draw the graph. No, I'll just draw the graph. Okay, and we have certain points. Okay, we have certain points, square, and we have circles, right? So I'll just draw three lines over here. I'll just draw three lines over here. Okay, so this is at x equals to 1. Then yeah, we have at x equals to 2. Then we have this line at x equals to 3. Okay, similarly I'll just draw this line at x equals to 1. Okay, y equals to 1. Then here at y2 and here at y3. Okay, so we have these three lines, right? So this is x, independent variable, this is dependent variable, and this is 0, 0. Okay, so this is 1, 2, 3. This is again 1, 2 and 3, and we have two circles at 1, 1 and 1, 2. Okay, so we have two circles, yeah, at 1, 1, okay, and at 1, 2, and we have three squares, 2, 3, 3, 3, 3, 2. Okay, so 2, 3, 2, 3, yeah, 2, 3, 3, 3 and 3, 2. Okay, 2, 3, 3, 3 and 3, 2. So these are three squares that we have. Okay, so these are three squares that we have, and we have a diamond shaped point, that is the unseen data, that is at 2, 1. Okay, we have a diamond shaped point. Okay, so yeah, we have a diamond shaped point. ये क्या कह रहे हैं, हमारे पास एक डायमंड शेप्ड पॉइंट है. तो कहाँ पर है? दैट डायमंड शेप्ड पॉइंट इज एट 2, 1. ओके, दैट डायमंड शेप्ड पॉइंट इज एट 2, 1. अब ये क्या पूछ रहा है? ही आस्क्स दैट the number of minimum odd values of k in the KNN so that this diamond shaped data is assigned a label square. आपको we have to assign this diamond shaped data, okay, this class label, no, that we have to assign this class label as square. Okay, the class square should be assigned, okay, to this diamond shaped point. So firstly what I'll do is I would use as a minimum odd value. So now let us see 1NN, let us see 3NN, and let us see 5NN. Okay, so in one of these it should be assigned a class square. So we have to find minimum. Okay, we have to find minimum. So very simple. Okay, so let us just calculate the distance. Okay, firstly calculate the distance. This distance is 1. Okay, and yeah, this distance is how much? This is from yeah, 1 to 3. This distance is 2. Okay, then this distance and this distance would be same. Okay, so this would be how much? So we have 1 and 1, so this would be √2, and this distance would be √2. Okay, so again √2, and now we have to calculate this distance. So what would be this distance? So this point is how much? Yeah, this is 2, 1. Okay, and this is how much? This is 3, 3. So point 2, 1 to distance 2, 3, 3 distance. So that would be 2 minus 3, 1 square plus 4 plus 4. Okay, plus 2 square. Okay, 1 square, yeah, plus 2 square. So that would be under root of 5. Okay, so 4 और 1 5, correct. This would be under root of 5. So this distance is 5. So now if you just check the nearest points, what is the first nearest point? If I just use 1NN classifier, okay, if I use just 1NN classifier, so what would be the first nearest point? So using 1NN classifier, the class would be how much? What would be the class? The class would be circle. Okay, the class would be circle because this is the nearest point. Okay, this is the nearest point if I use 1NN classifier. If I use 3NN classifier, so what are the nearest points? So I have I have this as the nearest point, I have this as the nearest point, and this as the nearest point. Okay, so I have two circles and one square. Okay, I have two circles and one square. So that means what is the majority vote? The majority vote is that again it would be a circle. Okay, majority vote is that again it would be a circle. Okay, now if I use 5NN classifier, so along with these three I would be having two squares also. So now majority voting would be what? Majority voting would be square. Okay, now majority voting would be square. So what is the answer? So answer is the minimum odd value is 5. Yes, I think every one of you have got it correct. Okay, yes, correct beta. Sidhu, Harshit, Lucky, yeah, ठीक है बच्चा, सही है, सही है, सभी का ही ठीक है ना? तो दिस इज हाउ वी हैव टू सॉल्व दिस. आई होप यू गॉट द लेवल नो व्हाट गेट हैज आस्क्ड. तो आई थिंक आप कर लोगे, मुझे ऐसा लगता है कि वी कैन डू दिस. ठीक है, चलिए. तो इट इज 11:43. we'll take a break of around 15 minutes. We'll take a break of around 15 minutes and let us meet at 12 p.m. Okay, let's meet again at 12 p.m. Okay, break for 15 minutes. ठीक है बेटा, चलो go freshen up yourself and we'll start with the new algorithm, that is naive Bayes algorithm. Okay, चलिए. ओके सो या गाइज आई फर्स्टली एक बार मैं देख लेता हूँ कि कल वाला लेक्चर हुआ है कि नहीं हुआ. ओके तो मैं एक बार कर देता हूँ आपके लिंक में ही ना, आपके उस लिंक में ही वो आ जाएगा. आई विल जस्ट सी टू दिस. देखो ऑलरेडी इट इज एडेड. आप देखो ऑलरेडी दिस लेक्चर 6 इज एडेड. नो सपोर्ट वेक्टर मशीन आप एक बार चेक करिएगा. ठीक है ऑलरेडी दैट इज एडेड बेटा. सपोर्ट वेक्टर मशीन लेक्चर जो है ऑलरेडी एडेड है. आप एक बार लिंक दोबारा से चेक करना. ठीक है आप एक बार लिंक चेक करो. देखो ये पूरा एडेड है ये वाला. ठीक है तो मेरी तरफ से दिस इज देयर एज लेक्चर 6. ओके तो वी हैव दीज लेक्चर 2 3 4 5 एंड दिस इज 6th. ओके मैं एक बार रिफ्रेश भी कर देता हूँ बेटा. ये है मेरी तरफ से दैट इज एडेड. देखो लेक्चर 6 इज एडेड फ्रॉम माय एंड. तो आप एक बार इस लिंक को ओपन करो. ठीक है मैं एक बार मैं पेस्ट भी कर देता हूँ. इफ यू वांट आई विल पेस्ट द लिंक एज वेल है ना. जस्ट डोंट वरी. मैं अभी आज क्लास के एंड में आई विल पेस्ट द लिंक एज वेल. ठीक है बेटा एडेड है. देखो लेक्चर 6 इज एडेड और आज वाला मैं ऐड कर दूंगा इसमें. ठीक है अच्छा गेट सेट को. ठीक है ठीक है ठीक है मैं एक बार वो भी ट्राई कर लेता हूँ. गेट सेट लॉगिन करके भी एक बार मैं ट्राई करता हूँ. ठीक है जस्ट डोंट वरी. चलो मैं एक बार कर लेता हूँ बेटा. मैं बाकी लिंक भी आपको पेस्ट कर दूंगा यहाँ पे जाके ना. लिंक ऑल्सो आई पेस्ट इट. तो वहां पे भी आप देख सकते हैं. ठीक है चल ओके तो नाउ let us start with the next algorithm. Okay now let us start with the next algorithm that is naive Bayes classifier. ठीक है मैं एक next algorithm से मैं शुरू करूंगा. Okay that is naive Bayes classifier. ठीक है तो new algorithm that is naive Bayes classifier. Okay and the name itself is very clear. The name is very clear. naive Bayes classifier में तो it is a supervised machine learning algorithm used for classification task and that is based on the Bayes theorem. ठीक है correct that is based on the Bayes theorem. तो this naive Bayes classifier no that is based on Bayes theorem. तो मतलब ये Bayes theorem को use करता है for classifying the probabilities. okay for classifying the probabilities. okay तो जहां पर भी जैसे फॉर एग्जाम्पल मतलब इट इज अ probabilistic classifier. ठीक है इट इज अ probabilistic classifier. जैसे कि लॉजिस्टिक था ना द लॉजिस्टिक रिग्रेशन वाज अ probabilistic classifier. okay तो सिमिलरली naive Bayes classifier is also a probabilistic classifier. okay naive Bayes classifier is also a probabilistic classifier which calculates the probabilities. okay which calculate the probabilities right. And it assumes and yeah this is the assumption that one feature in the model is independent of the other feature. okay this is the assumption right. you have to understand, you have to just learn it that one feature of the model is independent of the another feature. okay so in other words each feature contributes to the prediction with no relation between each other. very important. okay so this is the assumption of naive Bayes classifier and this is highly used in classifying articles. okay this is highly used in classifying articles. that is why I say जब भी आपको LLM पढ़ना है whenever you need to study LLM first focus on the basics of NLP. ठीक है and before focusing on the basis of NLP first focus on this naive Bayes classifier because they all are I mean related to each other. ठीक है, because these all are related to each other, because without naive Bayes you won't be able to understand the Bayes theorem. Okay, you won't be able to understand the NLP. Okay, and NLP के बगैर you won't be able to understand the LLMs. तो somewhat or the other the concepts are used there. Okay, तो अब ये basics है बेटा. This is the basics how naive Bayes algorithm is used to predict. Okay, and it has a very good I mean a very important weightage, very important role in classifying the articles. Okay, whenever you have to predict the word, okay, whenever you have to predict the word in a big article, there exactly we use naive Bayes, and it is used in spam filtration, then it is used in sentiment analysis and natural language processing. Okay, NLP, अगर if anyone is serious for NLP, उसके लिए बेटा ये रामबाण है. Okay, for this is bread and butter for that candidate. Okay, whosoever is I mean focused to study or to do research in NLP, for that this is very important. ठीक है बच्चा, चलो अब यहाँ पे firstly what we'll do is we'll try to understand what exactly a conditional probability is. Okay, firstly we'll try to understand what exactly a conditional probability is. ठीक है, अब जैसे मान लेते हैं कि okay, for example we just assume that we have two independent events. Okay, we have two independent events, right? Okay, or two events. Okay, not independent, I'll say we have two events. Okay, we have two events. Okay, not independent, I'll say we have two events. Okay, A and B. Okay, we have two events A and B. Okay, and I need to calculate the probability of A given B. Okay, I need to calculate the probability of A given B. So this conditional probability is calculated as P of A intersection B upon probability of B. Okay, so this we can calculate it as the probability of A intersection B upon probability of B. So this is how a conditional probability works. Okay, so what does this mean? It means that probability of A given B. Okay, so what does this means? So it means that probability of A given B. Okay, what does it mean? It means probability of A given B. ठीक है, क्या मतलब हो गया? probability of A given B. ठीक है, okay, चलिए अब I have certain one more, yeah, we can just discuss one more thing in here. If I need to calculate probability of B given A, if we need to discuss probability of B given A, so that would be how much? Probability of B intersection A upon probability of A. And what is B intersection A? So for these two events, this is B intersection A. Okay, this is known as B intersection A. So probability of B intersection A upon probability of A. So this is how conditional probability is defined. Okay, this is how conditional probability is defined. So I want you to do this question. Okay, try this question. Okay, the rest questions I'll give you as homework. Okay, firstly just try this question. Everyone try this question. A coin is tossed 2 times. I need to find P of y by x if x is at least one head and y is no tail. करिए बेटा, I'll wait for a minute, just calculate it. Let's see how to calculate this. Very simple, no? So what is x? X is what? X is at least one head. So see, firstly, what is the sample set here? Okay, here what is the sample set? So the total possible outcomes. So what can be total possible outcomes? So we can have HH, we can have HT, we can have TH, and we can have TT. Okay, and what is x? X is at least one head. So we can have HH, we can have HT, we can have TH. And what is y? Y is that no tail. Okay, y is that no tail. So we can have HH only. Okay, we can have HH only. Now what we need to find? We need to find P of y by x. Okay, P of y by x. So what is P of y by x? Y intersection x upon P of x. Okay, y intersection x upon P of x. So what is y intersection x? Only a single is there, no? HH. This is only y intersection x. So that would be how much? Yeah, so that would be 1. Okay, this would be 1 upon how many number of events are there in x? X total I have 3. So or we can also write this way. Okay, we can also write this way. So this is 1 by 4 upon 3 by 4. Okay, so you would be getting 1 by 3. I think this is more better way to write it, no? You will get it very clearly. Okay, so that is, yeah, 1 by 4 upon 3 by 4. So that is equals to how much? That is equals to 1 by 3. ठीक है, चलिए. अब now this is how a conditional probability works. Okay, this is how a conditional probability works. अच्छा, अब यहाँ पे you have to do this as homework. Okay, there are certain questions on conditional probability, so you have to do this as homework. Okay, this as homework again on conditional probability, this as homework, then yeah, this again as homework, and this again as homework. Okay, on the conditional probability. ठीक है, on the conditional probability. अब now we have Bayes theorem. Okay, I give you 4 questions for homework because already you have studied, no? Because already you have studied that conditional probability. Nothing big to do. Okay, nothing big to discuss in that. So easily you can do this. Okay, and I'll give you the answers in the end. Just don't worry. Okay, I'll give you the answers in the end. Okay, just don't worry. Acha, अब now let us see what exactly Bayes theorem is. Already you know it, है ना? Already you know Bayes theorem. ठीक है? Now let us see what exactly Bayes theorem is. So now I'll make you understand Bayes theorem by giving you a certain example. Okay, for example, we have box A. Okay, for example, we have box A. Okay, we have box B, and we have box C. Okay, we have box C. So we have a total of 3 boxes. We have a total of 3 boxes. Okay, acha, up now box A has certain okay, for example, these are 3 machines, right? These are 3 machines. So machine A, okay, machine A manufactures certain components. Okay, just try to understand difference between conditional and Bayes theorem. Okay, for example, machine A manufactures certain components. Okay, so it manufactures 30%, 33, matlab all manufactures equal components. 33.33% is manufactured by machine A. Okay, 33.33% of the goods are manufactured by machine B, and 33.33% of the goods are manufactured by machine C. Okay, so this I have done. Acha, ab now certain defective items are produced by machine A. For example, machine A has produced 5% of the defective items, okay, of this 33.33. Then machine B produces 7% of the defective items. Okay, this is the defective items. Okay, this is defective items, and machine C produces 6% of the defective items. Okay, of the goods that are manufactured. Okay, okay, now, okay, now I just take a bag over here. Okay, what I'll do is I'll just take a bag over here. Okay, what I'll do is I'll just take a bag over here, and the components would be collected here. Okay, I'll just take a bag over here, and the components would be collected. Okay, so up now you can understand that here certain good components would be there, and certain defective components would also be there. ठीक है, तो here certain good components would be there, and certain defective components would also be there. So we have certain good and defective, both components would be there. Okay, certain good components and certain defective components are there. Okay, चलिए, अब now what all things we have been given. So I am given with what? I am given with probability of A. What is the probability that machine A has manufactured? That is 1 by 3. What is the probability that machine B has manufactured a good? That is 1 by 3. What is the probability that C has manufactured the good? That is 1 by 3. ठीक है. Now what I have been given, I have been also given that probability that the good is defective, given that it is manufactured by A. How much is that? That is 0.05. Okay, I'll just take 0.05. Okay, I'll not take 5% of this. I'll just take 0.05 just for an example. Okay, just for an example, I'll take that the probability that machine A has manufactured defective, that is 0.05. Probability that machine B has manufactured a defective component, that is 0.07, and probability that machine C has manufactured a defective component, that is 0.06. Okay, just for an example, just a random example I am taking, that yes, these are the probabilities. Okay, so conditional probability that A manufactures defective component 0.05, conditional probability that B manufactures defective component 0.07, conditional probability that C manufactures defective component 0.06. Okay, so this I have been given. Okay, this is given to me. Now what I want is, I just took a random component from here. Now what I did is, I just took a random component from here and I found that random component is a defective component. What I did, I just put a random component. I just took a random component from here. What I did, I just took a random component from here and I found that random component is a defective component. Tell me the probability that is from machine A. Tell me the probability that is from machine A. ठीक है, देखो अभी तक what I was doing, just see what I was doing. अभी तक what I was doing, I was actually taking the straight conditional probabilities. I just took the straight conditional probabilities. What is the straight conditional probabilities? It is defective component from machine A, defective component from machine B, defective component from machine C. But now what did I ask you? I am asking you कि भैया मेरे को defective component तो मिला, this is given. Defective component is given. मुझे ये बताओ ये A से आया है. Okay, just tell me that it came from A. So the scenario or the scenarios or the scenes where we have to calculate the reverse conditional probability, the scenario where we have to calculate the reverse conditional probability, that is actually modeled. Okay, that is actually calculated using Bayes theorem. Okay, that is actually calculated using Bayes theorem. So this is the importance of Bayes theorem, where we have to calculate reverse conditional probability. So probability of given that it is defective and came from machine A, तो इसका जो formula होता है, तो here the Bayes theorem would be working in this way. Total probability that item is defective upon probability of D by A into probability of A. And if I open this, if I open the denominator, so I would be getting P of D by A into probability of A upon probability of D by A into probability of A plus, okay, plus probability of D by B into probability of B, okay, plus probability of C probability of D by C into probability of C. So this is the Bayes theorem that you have to remember. Okay, ये Bayes theorem है जो कि आपको याद रखनी है. Okay, this is the Bayes theorem that you have to remember. Okay, so this is how these all are calculated. Okay, this is how which you have to remember the Bayes theorem. ठीक है, अब now this theorem is utilized. Okay, अब now this theorem is utilized to calculate the naive-Bayes classifier. Okay, the prediction using naive-Bayes classifier. This theorem is utilized to calculate the prediction using naive-Bayes classifier. Okay, this theorem is utilized to calculate the prediction using naive Bayes classifier. Okay, so now firstly tell me the answer of this. Okay, firstly tell me the answer of this. I need to identify that the component is defective. Okay, the component is defective, but I need to predict that that it came from, what is the probability that it came from machine A. The component is defected, but I need to predict that it came from machine A. So how to do this? Yeah, calculate the answer. So how to do this? We know P of D by A, that is 0.05. Okay, so that is 0.05 into probability of A is 1 by 3. Okay, so 0.05 into 1 by 3 plus, what is the probability of P of D by B? That is 0.07. 0.07 into 1 by 3 plus 0.06 into 1 by 3. Okay, 0.06 into 1 by 3. Okay, so now just tell me the answer. What is the answer of this? Okay, so that would be how much? So that would be around 0.83. I think, sorry, 0.277. Yes. So I think we'll be getting an answer of 0.277. Okay, so we'll be getting an answer of 0.277. So this would be the answer, 0.2778. I think this would be the answer, 0.2778. So this is the probability of A by D. Okay, so this is the probability of A by D. So that means the defective, that means that item is defected, but what is the probability that it came from A? That is 0.2778. Okay, that is 0.2778. The probability that the item is defected would be 0.2778. So this is how we have to solve the Bayes theorem. Okay, so what is Bayes theorem? That is reverse conditional probability. ठीक है, what is Bayes theorem? That is reverse conditional probability. Okay, Bayes theorem क्या हो गया? That is reverse conditional probability. ये बस reverse conditional probability की तरह act करता है. Okay, so it acts as reverse conditional probability. अब now how this algorithm is utilized? See, I have certain questions on Bayes theorem, so this you would be doing as homework. Okay, and this you would be doing as homework. Okay, very simple. If you are clear with the concept, I think easily you can do these two questions, okay, as homework. Okay, now yeah, again I have one question on Bayes theorem, so this you would be doing as homework. Okay, because already you have studied this in mathematics, right? So that is why I won't be touching this again. Okay, I won't be touching this again. ठीक है, चलिए अब यहाँ पे let us see how this Bayes theorem is utilized. How this Bayes theorem is utilized to actually calculate the prediction. okay, in this naive Bayes classifier. Okay, how to utilize this Bayes theorem to calculate prediction in this naive Bayes classifier. Okay, chaliye, ab what is the new instance here? What is the new instance here? We have outlook is sunny, temperature is cool, humidity is high, and wind is strong. So this is the unseen data. Okay, this is the unseen data. I need to predict whether I would go to play tennis or not when conditions are that outlook is sunny, temperature is cool, humidity is high, and wind is strong. Okay, and wind is strong. So just watch it carefully. Okay guys, it would take around 15 to 20 minutes, but yeah, please watch it carefully. Okay, so you have to understand certain important concepts here. Okay, chaliye, ab now we have almost 14 points here. Okay, we have a total of 14 points here. Okay, we have a total of 14 points here. So I think the last one is not visible. I think now this is visible. Okay, so we have a total of, correct, we have a total of 14 points here. Okay, acha, ab here we have to train the data. Okay, and use naive Bayes classifier for the predictions. Chaliye, ab how to do this? So here, firstly what we'll do is, firstly we calculate. Okay, firstly what we do is, you have to remember the name. Firstly what we do is, we have to calculate the priors. Okay, priors ya fir prior probability. Okay, firstly what you have to do is, you have to calculate prior or prior probability. So what is prior or prior probability? The probability of the target variable. Okay, and this is a binary target variable, so we have no and yes. So how many no's are there? So we have a total of 4 and 5 no's are there. Okay, so what is the prior probability? The probability of class no, probability of class no is 5 by 14, and probability of class yes, so I can just count yes: 1 yes, 2 yes, 3 yes, 4 yes, 5 yes, 6 yes, 7 yes, 8 yes, and 9 yes. So a total of 14, yeah, a total of 14 points are there. So 9 by 14 as the probability of yes, and 5 by 14 as the probability of class no. Okay, तो इसको हम बोलते हैं priors या फिर prior probability. Okay, please just write all these points. Okay, write all these things, so important things. Okay, so because in the sample paper 2024 question of naive Bayes was there, in gate 2024 question of naive Bayes was there, in 2025 also question from naive Bayes was there, because that is an important one. Okay, chaliye, okay, so these are known as prior probability. Okay, the probability of class no and probability of class yes. Ab after this, okay, after this priors we have calculated. Ab now next is that we calculate the conditional probabilities, or we say as likelihood probabilities. Okay, we calculate the conditional probabilities, or we say as likelihood probabilities. Okay, ab now firstly you tell me, okay, firstly you tell me for the feature outlook how many classes are there. Firstly you tell me for the feature outlook how many classes are there. Sunny, overcast, rain. Okay, we have 3 classes. So for the feature out कौन सा था feature? For the feature outlook, yeah, for the feature outlook how many classes are there? So I have a total of sunny, overcast, rain as 3 classes. So I have sunny, okay, I have overcast, and I have rain. ठीक है, अब how many sunnies are there? Let me count how many sunnies are there. 1 sunny, 2 sunny, 3 sunny, 4 sunny, 5 sunny. So I have a total of 5 sunnies. How many overcast are there? 1 overcast, 2 overcast, 3 overcast, and 4 overcast. So I have a total of 4 overcast. And how many rains are there? So we have 1 rain, 2 rain, 3 rain, 4 rain, and 5 rain. Okay, a total of 5 rains are there. So 5 plus 5 10 plus 4 14. ठीक है, 5 plus 5 10 और 4 14. So we have total of 14 sample points. Okay, अब for sunny, how many yes and how many no's are there? Okay, so this calculation actually happens in the back end. You just have to use the naive Bayes classifier from scikit-learn. This calculation happens in the back end, but still you should remember कि भैया पीछे चल क्या रहा है, what exactly is going on. तो आपने वो क्या कहते हैं लाइब्रेरी तो लगा दिया, but what exactly is going on, how to tune the hyperparameters, तो उसके लिए ये आपको करना जरूरी है. Okay, yeah. चलिए अब यहाँ पर फॉर सनी हाउ मेनी नोज एंड हाउ मेनी येस आर देयर? तो फॉर सनी आई हैव 1 नो, आई हैव 2 नो. ओके, फॉर सनी या आई हैव 3 no's and 1 yes. 3 no's, 1 yes, 2 yes and yeah 3 no's. Okay, 2 yes and 3 no's. So I have 2 yes and 3 no. Up similarly for overcast and rain, let us calculate. For overcast 1 yes, for overcast 2 yes, for overcast 3 yes and for overcast 4 yes. Okay, so for overcast all yes are there. Okay, for overcast all we have yes class. So we have 4 yes and 0 no. And for rain, for rain we have 1 yes, we have 2 yes and we have 1 no. 1 no, 2 yes, 3 yes, 1 no and 3 yes, 2 no. Okay, so we have 3 yes and 2 no. Okay, I'll just check again. For rain we have 1 yes, we have 2 yes, we have 1 no. 1 no, 2 yes and we have 3 yes, 1 no. And rain, yeah, so we have 2 no and 3 yeses. Okay, so this we have calculated. Ab now we have to actually calculate the conditional probability of what? We have to calculate the conditional probability or likelihood probability that it is given that I would go to play. Okay, now see, I have to calculate only the conditional probability. No reverse conditional probabilities are being calculated here. मैं सिर्फ conditional probability निकाल रहा हूँ. Only conditional probability is being calculated here. So given that I would go to play, what is the probability that it is sunny? Okay, what I'm calculating? Given that again I'll just see. I'll see. Yeah, I would calculate what? Yes. So I would calculate what? I would calculate probability that given that I would go to play tennis. I would go to play tennis. What is the probability that it is? Yeah, what is the probability that it is sunny? What is the probability that it is sunny? Okay, so up now how many yes are there? A total of 9 yes are there. Okay, a total of 9 yes are there. And how many yeses are there for sunny? These 5 sunnies, how many yes are there? A total of 2 yes is there. So this is known as likelihood probability. Okay, this is known as likelihood probability. Never get confused. This is the yes. Okay, total yes there in the target variable. Okay, that is the total yes in the target variable. And what is this 2? For yeses, for 5 sunnies, how many yeses are there? Okay, for 5 sunnies, how many yeses are there? Now I want to ask you one question. Tell me the probability of sunny given that I won't go to play tennis. Tell me the probability that it is sunny and given that I won't go to play tennis. So how many no's are there? Firstly tell me how many no's are there? So a total of 4 no's are there. And in this sunny, how many no's? From these 5 sunny, how many no's are there? A total of 3 no's are there. So that means the probability that I won't go to play tennis कितना है? 5 है ना? अच्छा 5 are there, sorry, 4 नहीं, 5 are there. Yeah, so probability that I would not go to play tennis given that it is sunny, so that would be how much? That would be 3/5. So what is this 3/5? This 3/5 is probability that I won't go to play tennis given that it is sunny. Okay. Or what is this 2/9? Probability that I would go to play tennis given that it is sunny. So this way I have calculated all the conditional probabilities. Okay, this way I have calculated all the conditional probabilities. Okay, similarly for overcast, let us calculate this for overcast. Things would get really very clear. Probability that I would go to play. Probability that I would go to play. Condition is it should be overcast. Okay, and the next is probability that I won't go to play. Condition that it is not overcast. It is not overcast. Okay, so yeah, So for overcast, a total of 4, a total out of this 9 yes. Okay, out of the 9 yes, how many yeses are there for overcast? 4 overcast yeses are there. And out of the 5 no's, how many no's are there for overcast? There is no overcast. So that means the probability of going for playing tennis given if it is overcast, that is 4 by 9. And what is the probability that I won't go to play tennis okay, given if it is overcast? The probability is 0. ठीक है, तो correct. So this is how we need to calculate the conditional probabilities. Okay, this is how we need to calculate the conditional probabilities. One last thing I would more do, yeah, that probability that I would go to play, it is given, find the probability that it is rainy. Okay, find the probability that it is rainy, and probability that I won't go to play given matlab the probability that it would be rainy and given that I won't go to play. So what is the probability? So out of 9, how many yeses are there? So I have 3 yeses, okay, for rainy. And out of 5, what is the probability that I won't go for playing tennis? Okay, that is 2 by 5. Given that I'm not going to play tennis, it is rainy, so that is 2 by 5. Okay, that is 2 by 5. So yeah, so these are known as the conditional or the likelihood probabilities. Okay, these are known as the conditional or likelihood probabilities. So similarly, you have to do this practice for temperature, humidity and wind. Okay, similarly you have to do this practice for temperature, okay, temperature, humidity and wind. Okay, so similarly you have to do this practice for temperature, humidity and wind. This is as a homework, and just match with the other page. Okay, just match this with the other page. So I have calculated this for for temperature. Okay, I have calculated this for humidity and I have calculated this for wind. ठीक है, तो मैंने wind के लिए भी निकाल दिया. I have calculated this for temperature and humidity. ठीक है, चलिए, तो these conditional probabilities I have calculated. Okay, चलो, अब यहाँ पर what is the x dash that is given to me? X dash is outlook is sunny, temperature is cool, humidity is high, wind is strong. This is the unseen data. Okay, this is the unseen data. On this unseen data, I need to predict. Okay, this is the unseen data. On this unseen data, I need to predict. भैया क्या मैं टेनिस खेलने जाऊंगा कि नहीं? Just tell me whether I would go to play tennis or not. तो देख लेते हैं. अब यहाँ पर I have gathered all these points. Probability of outlook. See here, outlook is sunny. Outlook is sunny by yes. I have taken this when outlook is sunny by play, that I have gathered here. Okay, temperature is cool by play, 3 by 9. Cool by no play, that is 1 by 5. Okay, humidity is high by play, that is 3 by 9. No high by no play, that is 4 by 5. So similarly, I have gathered all these likelihood probabilities. Okay, all these likelihood probabilities. Now I would be using a maximum a posteriori rule. Okay, now what I'll do is I would be using a maximum posteriori rule. Okay, now what is that? Very simple. अब now I need to predict what? अब मुझे क्या निकालना है? I need to predict what? Two things I have to predict. Whether I would go to play tennis given that x dash, and I want to calculate the score that I won't go to play tennis given x dash. भाई मुझे यही तो calculate करना है ना? This only I need to calculate. Okay, what I need to calculate? I need to calculate that whether this x dash, whether at x dash the class is yes or no. बस यही निकालना है. Okay, this only I need to calculate कि on this x dash the class is yes or no. So here I would be using a maximum posteriori rule, that is nothing, that is related to Bayes theorem. I'll just tell you how. Okay, I'll just tell you how. That is nothing, that is related to Bayes theorem. So what is a maximum posteriori rule? So conditional probabilities are given. Okay, conditional probabilities are given. So what are these? These are the reverse conditional probabilities. I hope you are getting the feeling of that, जो कि अभी हमने किया. Okay, just now we have done it. I hope you are getting that feeling, the essence of this. We need to calculate reverse conditional probabilities. Okay, we need to calculate the reverse conditional probabilities. We need to calculate this, the reverse conditional probabilities. अब calculating P of yes by x dash and no by x dash, we use indirectly Bayes theorem. That is known as what? Maximum a posteriori rule. Okay, that is what? So yes by x dash would be sunny by yes into cool by yes into high by yes into strong by yes into a probability of yes. Okay, why I choose sunny, cool, high and strong? Because in the x dash I had outlook as sunny, in the temperature I had outlook as temperature as cool, in the humidity I had this as high, and in the wind I had this as strong. So what I have done is I used sunny by yes, cool by yes, high by yes, strong by yes into probability of yes, which is similar to what? Which is similar to what? That we have used here in the Bayes theorem. Okay, which is similar to what? That we have used in the Bayes theorem. So in that naive Bayes classifier, that is known as a maximum posteriori rule, but that is somewhat similar. मतलब the fundamental is this only, where I need to calculate that बताइए कि ये जो defective item है machine A से आया है. I wanted to calculate what? That this defective item came from machine A. So how did I calculate? I used this Bayes theorem, okay, where P of D by A into P of A upon total probability. So here this is how the these questions are calculated. But for the naive Bayes classifier, reverse conditional probability, how that are calculated? Those are calculated in this way, which you have to learn. So that is calculated in this way, that sunny by yes. Okay, I need to calculate what? Yes by x dash. That is what? Reverse conditional probability. So how to calculate it? Sunny by yes, cool by yes, high by yes, strong by yes into probability of yes. Then similarly I would be calculating here sunny by no, cool by no, high by no, strong by no into probability of no. So I would be getting these two scores here. Okay, these are not probability. I am again saying these are only the maximum posteriori. Matlab these are the scores. Okay, these are the scores here. So here which score is bigger? Here which score is bigger? The score of going to play. The score of going to play given x dash is less than the score of not going to play. Okay, as compared to this not going to play given x dash. So that means since P of yes by x dash is lesser, this score is lesser than P of no by x dash, so that means we can label the unseen data to the class no. Okay, that means when outlook is sunny, temperature cool, humidity high, wind strong, the person would not go to play tennis. The person would not go to play tennis. So this is how naive Bayes classifier works. Okay, this is how naive Bayes classifier works. Okay, so guys, here after calculating the scores, if question says bhaiya tell me the probability that the person would go to play tennis, we have to normalize things. How to normalize things? We have to calculate P of yes by x dash. That is nothing, that is just a normalization approach that everyone knows. That is 0.0053 upon 0.0053 plus 0.026. So I would be getting, we have 20% chances that person would go to play tennis. Under what conditions? When outlook is sunny, temperature cool, humidity high, wind strong. And the person has 79.53% chances that he won't go to play. Under what conditions? Under the conditions when outlook is sunny, temperature is cool, humidity is high and wind is strong. So this is how a naive Bayes classifier in the backend works. This is how a naive Bayes classifier, okay, works. Okay, so in the backend all these calculations takes place. Okay, in the backend all these calculations takes place. Okay, so this is known as posterior probability. Okay, this is known as posterior probability. Okay, this is known as posterior probabilities. So that means you have to calculate prior, then likelihood, and in the end we calculate posterior probability. Okay, in the end we calculate posterior probability. So I'll just write it here. Yeah, so first one is prior, second one is likelihood, okay, and the third one is posterior probability. Okay, so I have number of questions I would be giving to you, okay, and based on the same concept, based on the same concept, because this is how a naive Bayes classifier works. This is how a naive Bayes classifier works. Okay, तो इस तरीके से काम करता है. I have certain questions I would be giving you, okay, where you have to solve this. Okay, you have to solve this simple question, not a bigger data set, very simple question. You can do this as a homework. Okay, yeah, you can, yes, do this as a homework. Then I have this question, this I would be solving with you. Okay, this question I would be solving with you because this is bit different. Okay, but firstly I'll give you time. You just, if you want to note it down anything, you can do it. I'll wait for a minute. Okay बच्चा, I'll wait for a minute. आप इसको लिखना चाहो लिख लो, जो भी लिखना है आप लिख लो. Yeah, I hope now this is clear. I hope now I'm audible. Yes, I hope I'm audible now. Done. ठीक है. तो here I told you that we have yeah, I just told you that either way you can learn. Okay, either way you can learn that if you have posterior I mean the posterior probability is probability of a hypothesis A on the observed event B. I mean by definition if you want you can learn. Okay, by definition if you want you can learn. Okay, or by that example if you want you can learn using that example also. Any way you are comfortable you can learn it. Okay, any way you are comfortable you can learn it. So what is likelihood probability? It is the probability of evidence given that the probability of hypothesis is true. So this is how it is defined. Okay, then we know prior, we know posterior, we know likelihood. Okay, and what is evidence probability, also known as marginal likelihood? So it is the overall probability of observing any event. Okay, overall probability of observing any event. For example, what is the probability of observing a sunny day in this feature outlook? Okay, what is the probability of observing a sunny day in this feature outlook? So how many sunnies are there? One sunny. Okay, we have two sunny, we have three sunny, four sunny, five sunny. So that means 5 by 14. Okay, so probability of this event sunny, probability of this evidence sunny or this event sunny is 5 by 14. So evidence sunny. So I'll just write probability of evidence sunny in this feature outlook. So when outlook is sunny, no, when outlook is sunny, so what is the probability? So it is 5 by 14. Okay. So this probability is what? This probability is 5 by 14. So this is how, yeah, this is how we can actually calculate, okay, these probabilities. This is how we can calculate these probabilities. Okay. So this is how we can calculate these probabilities. Right. So now this question is for homework. Okay, now let us just focus on this question, right? So I just want you that firstly just read this question, no? Then let us do this question. Okay, so what he says that a spam filter uses a naive-Bayes classifier. Okay, a very genuine application, right? A very genuine application, and actually this may be asked number of times. Okay, very genuine application. Now what he says a spam filter uses a naive-Bayes classifier. I hope you are getting it, no? What exactly spam is? By whenever you open a Gmail, no, certain mails automatically are transferred to the spam. How does that happen? So basically that is nothing, that is just an result, that is just a result of naive-Bayes learning algorithm. Okay, that is just a result of what? Naive-Bayes learning algorithm, right? So how naive-Bayes learning algorithm is utilized for all these applications? So it is utilized based on presence of certain words. Okay, it actually sees certain words in the class in the mail. Okay, तो जैसे मान लीजिए आपके mail में, in your mail, for example, certain words such as offer, okay, such as we have words such as offer and click. He says that presence of these two words, no, they tell us that whether this mail is a spam or not. तो अब उसी में इन्होंने क्वेश्चन बना दिया. On that only they have made a question. They says कि भैया अगर ऑफर और स्पैम ये दो वर्ड है, अब आप नेव बेस को यूज करो. ओके, ट्राई नेव बेस एल्गोरिथम एंड बेस्ड ऑन दीज टू वर्ड्स ऑफर एंड स्पैम टेल मी व्हाट इज अ प्रोबेबिलिटी दैट दिस ईमेल इज अ स्पैम और एक्चुअली दिस ईमेल इज अ गुड वन. ओके, और मतलब आई मीन अ नॉर्मल वन. तो कैसे कैलकुलेट करेंगे, हाउ टू कैलकुलेट दिस? तो वी हैव टू यूज नेव बेस एल्गोरिथम. ओके, नेव बेस concept is clear. What we have to calculate? We have to calculate maximum of posteriori score. Okay, we have to calculate what? Maximum of posteriori score, that we have to calculate. Okay, but how to use this in this type of problems, I'll just tell you. Okay, so he says that probability that the algorithm is spam is 0.6. Probability that algorithm is not spam, this probability is 0.4. Okay, अच्छा, अब now word probabilities are given. Probability that given that the mail is spam, what is the probability that offer would come in this mail? तो we have 80% chances that अगर ये spam हुआ, if that mail is a spam, that means offer would be there in 80% of these mails. Okay, in 80% of mails we will be having that word offer. अब next is that मान लीजिए कि if the email is a spam, what is the probability that इसमें ये word आपको मिलेगा, you would get this word click, तो that is 0.7. okay, that is 0.7. okay, that is 0.7. ठीक है. अब next we are given, it is given that the mail is not spam. It is given that the mail is not spam. What is the probability that I would be having the word offer here? So this is 0.3. okay, it is given that probability, it is given that mail is not spam. What is the probability that I would be having the word click? So that is 0.2. okay, so these probabilities have been given to us. Okay, these probabilities have been given to us. अब ये देखो ये क्या बोल रहा है, I hope you are able to identify. ये दो probabilities कौन सी हैं? These are known as priors. अगर if you have understood the concept, I hope you are able to identify that these probabilities are what? These are priors. ठीक. अच्छा, now what are these probabilities? These are the likelihood probabilities. Okay, these are what? These are the likelihood probabilities. Okay, these are the likelihood probabilities. Okay, these are the likelihood probabilities. Okay, अच्छा, अब what we have to calculate? We have to calculate that given that a new mail contains both offer and click. अब एक नया mail आएगा. Okay, for example, this is the unseen data. Okay, we have a unseen data and this mail has the word offer. Okay, this mail has the word offer and this mail has the word click. Okay, this mail has the word click. We need to compute the posterior probability that email is spam. आपको क्या निकालना है? You need to calculate the posterior probability that email is spam. I hope now you are able to understand what exactly the posterior probability is and what exactly the how exactly this naive Bayes classifier algorithm would be utilized. Okay, तो backend पे बेटा यही calculation चलता है. In the backend this all happens. Okay, बस you after using the library you get the result. I hope you are getting this. तो in the backend ये पूरा calculation चलता है. तो after using this you get the result. ठीक है, अब देखते हैं. Now let us see how to calculate this. Okay, so we have the conditional probabilities, we have the prior probabilities. ठीक है, अब now what I'll do is I would use a MAP rule, maximum posteriori rule, and I would calculate that the probability of, I would calculate what? Probability of spam. Okay, I would calculate what? Probability of spam given that, क्या क्या given है मेरे पास इसमें मेल में I have the word offer and I have the word click. I need to calculate this posterior probability using MAP rule. So this is how I can calculate. This is offer by spam. Okay, this is offer by spam using MAP rule. Offer by spam into probability of click by spam into probability of spam. I hope you are able to understand this. Okay, so what is offer by spam? Yeah, what is offer by spam? That is 0.8. Okay, what is click by spam? Click by spam, that is 0.7. And what is the prior probability of spam? Prior probability of spam is 0.6. Okay, so if I just calculate, I'll get कितना आ जाएगा 0.336. Okay, so I'll get the answer as 0.336. Then next I would be calculating the posterior probability of not spam. Okay, next I would be calculating the posterior probability of not spam given offer and click. Probability of not spam given offer and click. So probability of offer given not spam into probability of click given not spam into probability of not spam. ठीक है, तो कितना आ जाएगा? तो yes, तो probability of offer given not spam, that is 0.3, and probability of click given not spam, that is 0.2, and probability of not spam is 0.4. Okay, so combinedly I would get this result as 0.024. I would get this result as 0.024. Ab now tell me which is greater. If I compare these two, which is greater? That is it a spam or not spam? So I think you can just see that probability of spam given offer and click is greater than the probability of not spam given offer and click. So that means what is that means कि this email would be classified as a spam. Okay, what is the result? So according to MAP rule, what is the result? So the result would be that the email is spam. ठीक है, तो automatically that spam email would go to your spam, not in your inbox. So this is how the classifier works. ठीक है, this is how the classifier works. Automatically it would go to the spam. तो बेटा this is the back end calculation जो कि किसी को पता ही नहीं है. मैं गारंटी के साथ बोल रहा हूँ, the data scientist working in the companies, majority of them doesn't know. Okay, so this is the calculation that actually happens in the back end. ठीक है, अब यहाँ पर what is the probability? What he said, he asked us to calculate what? He asked us to calculate the posterior probability. So what is the posterior probability? Very simple. So probability of spam, posterior probability. Okay, posterior probability of spam. So that would be how much? So it would be 0.336 upon 0.336 plus 0.024. We just have to normalize. Okay, we just have to normalize the things. So yeah, so we would be getting 0.933. Okay, so 0.933. So that means 93.3% chances are there that this is that it is a spam. ठीक है, this is spam. बोलो समझ में आया कि नहीं आया? तो अगर आ गया तो बेटा आई वॉन्ट लाइक्स एंड आई वॉन्ट शेयर. ओके, आई सपोज आप इतना मेरे लिए करोगे. बोलो क्लियर है कि नहीं है? चलो ठीक है ना. तो आई हैव गिवन यू अ लॉट ऑफ होमवर्क. Okay, I have given you a lot of homework, so please attempt those questions, and in the PYQ series we'll do certain more questions. Okay, in the PYQ series we'll do certain other questions as well. ठीक है बच्चा, तो today I'll end here with naive Bayes and KNN. Practice these questions and let us meet soon tomorrow. Okay, चलिए, thank you so much, and I'll see to that, I'll see to the I'll see to the get set go one. No, I'll see to the get set go one. Okay, just don't worry, I'll see to that. Okay, you'll get the link. Okay, or in this comment section I'll paste the link of that. Okay, तो आपको वहां से मिल जाएगा, just don't worry.